All right. Now we are going to do part two formulas. So in my book, part one has the first five topics, starting with equity, fixed income, derivatives, alternatives, and economics. In part two, we have topics of quants, portfolio, a lot of formulas here. FSA has some components, not formula, but you need to understand the what goes into the pension expense, etc. And corporate issuer has formulas similar to FSA. Ethics doesn't have formulas, but the main focus is going to be on quants portfolio because, and of course, FSA and corporate issuer, but quants is where there are a lot of formulas. Many of these formulas may not be asked in exam. Okay. But yes, you need to know the impact of that formula. So again, in the book, there is detailed discussion about all of these formula. You will see I've done in the class, covered it multiple times in full course, fast track. All of these formula, you will see the component of it. But here what we are doing, we are trying to write down all the formulas starting with quants. We'll first start with quants and we will just write down for a reference so that we don't miss out on them. Okay. Again, for detailed understanding, you'll have to check out the notes. Now, in quants also, the formula focus is going to be on the first two readings, which are actually broken down into five parts. Okay, so we'll be discussing all the formulas related to this multiple regressions. Okay, so first thing we will start with regression basics, that is multiple regression basics. Now, I'll repeat everything. Very important one thing here is that not everything is captured in the formula. Like the most important thing in the topic is about assumptions, which are violated, which test is done. We are not discussing that here. We are just discussing on the formulas. But yes, in the revision batch, I've covered that what test to be used and when. So the objective is here clear, just knowing the formulas. Okay. So we are just summarizing all the formula at one place. So I will focus on the various formulas. The first thing is the basic multiple regression model. So under the regression model, y equals to b0 plus b1 is what you did in linear. Here you will have multiple slopes, correct? Now, at the end, you also have error. Error, what is error? Error is the difference between what is expected and what is the actual. So please note out, error is also termed as residual error. Okay, and residual error formula, everyone should be aware, residual error is the difference between what you realized and what you expected. So the observed and the predicted value. We always say the observed value minus the predicted value of y. Y is here the independent factor or dependent. Y is the dependent factor. X is the independent factor. Everyone, B0 is intercept, B1 is slope. B0 is the value of y when B1 is 0. B1, that is the slope, is basically the delta, you can say, is the change in the dependent for every 1 unit of change in independent, holding all other constant. Yes, that is very important. Holding all other constant. That is the most crucial thing. Holding all other constant. Okay. Right. So that is the basic formula that we all should be aware. Now, in this topic, after this, there were assumptions which are very critical. So formula wise, this section, and then something again what you did in L1 is the ANOVA table. If you remember the ANOVA table where you have ANOVA is analysis of variance. Here the sum of square formula is very important, and based on that we calculate the R square. Yes. So what is sum of square total? Sum of square total, it is actually total variance. Is sum of square regression, which is explained or unexplained? This is explained. And sum of square error, error. Of this, if I want to calculate R square is sum of square regression over sum of square total. Remember this, higher the R square, the better it is. But the problem with R square is that it always increases as more and more, independent variables are added. So if you keep on adding more variables, R square automatically increases. That's why What is new in level 2 is that we calculate something called adjusted R square. Adjusted R square. I'll rather write it on a new page. Adjusted R square is something that we didn't do that in L1. So what is adjusted R square? Now I will be very straightforward here. There is a formula for adjusted R square, but you don't need to memorize it. I will write down the formula, but I'll repeat, more than memorizing the formula, in adjusted R square, you always have to remember adjusted R square is used for making the model more fit because the model is overfit. So we have to reduce that fitness. So to adjust that overfitting problem, we calculate adjusted R square. I will write down the formula, but let me be straightforward. Adjusted R square formula may not be tested. But yes, you need to know that adjusted R square is always less than or equal to R square. Yes, I will first write down that. That is more important. Adjusted R square is always less than or equal to. Mostly it is less than the R square. We want it to be higher. If you want to understand the quality of model, if you want to know the fitness of the model, sorry, the adjusted R square should be higher. Again, I'm writing the formula, the same formula, but it is not needed. It's a complicated thing. It is 1 minus a ratio of the degree of freedoms. The degree of freedom for total is n minus 1, and for the error, n minus k minus 1. K is number of independent variable. This is the degree of freedom of the error. So it's a degree of freedom of total over the degree of freedom of the error. Into we do what? Into we multiply that with the 1 minus r square. This formula, straightforward. No need to memorize it, but again, just for your reference. What I need to know more is this. All right. This will resolve the overfitting issue of the model. But there are two other variables which are used for analyzing the forecasting quality of the model and the fitness of the model. So for evaluating, for selecting between multiple models, in fact, I will say for selecting amongst models, or what is the selection criteria for this model? Selection criteria for this model, we select the model based on two things, based on their forecasting ability and based on the fitness or parsimonious, we say. So for this, we calculate something called AIC and BIC. AIC and BIC. AIC and BIC, again, you do not have to memorize it. Although I'm writing the formula here, if you notice the formula is n into log natural of SSE. SSE is sum of square error over n plus 2 into k plus 1. Now you will notice the difference here is the second part. No need to write the formula, just that you need to understand that amongst the two, which model will I select? Which model will I select? The one who, let's say there are several models and I have to select one. So I will choose the one which has lower values. Lower values. So we will always choose the lower values. The lower better. Lower is better. The lower is better. Remember, if there are several models, you will always choose the one where the AIC or BIC is lower. If they are compared with other models, when we compare the other models, if this AIC and BIC are lower, that means the model is of high quality. All right, that's it. No need to memorize the formula. All right. Reference, yes, you need to know what is the model used for. That is very important. All right. Now, there are some formulas for the fitness test. We do the F test for the models which are restricted and unrestricted. Now, there is no formula for this, but I will just give you a reference of what is a full model and what is a restricted model. First of all, let's take a model with three variables. So if I take B0 plus B1 x1 plus B2 x2 plus B3 x3 plus error. All right. Now here, how many independent variables you have? Three. One, two, three. Correct? Now, if I take a model which takes all these variables, such a model is called full model, which is also called unrestricted model, unrestricted model. So full model or unrestricted model, full model or unrestricted model. In this case, I will take all the variables. Just remember, in this case, I will take all the variables. But the other model is a restricted model. Restricted model, what you need to remember is that I will exclude some of the variables. So if I'm excluding some of the variable, that is called Q. Out of 3, if I'm excluding 2, then the variables I'm taking is 1. Now you need to know what is a full and restricted model. You don't need to remember any formula here. Okay, this both are called, they have a name, we call them nested model. So this is what is the, not the formula, but for your reference, these are called nested models. Yes, you need to know what is the nested model. It is a comparison of a full model and a restricted model. In restricted model, we drop some of the variables to understand whether the model is fit or not. Okay. Here, here we use the F statistic. You do not have to remember the F statistic, but that F statistic, you need to know the rejection point. Everyone, the rejection of the null. So if the S statistics is greater on the right side, then the critical value. In that case, remember our decision will be reject the null, reject the null hypothesis. When we reject the null, that means there is a relation amongst the variables. So the variables are, they are significant. So when we reject the null, what is our decision? Our decision is that the variables are significant. We will conclude the variables are significant. Okay. Now, in detail, I've explained about this very specifically, what is a joint F test and what is an overall F test or global F test, what is a null and alternative hypothesis there, and accordingly, what is the rejection point. Now, that micro level of analysis is the testing. We are not getting into the testing. There's no formula as such that you need to remember. In fact, in your notes, there is an F test formula, but F test formula, I have strictly told student, no need to memorize that formula. It's not even needed. F test statistic will be provided to you. Those who are with me in level 1, they know that I tell students not to memorize the test statistics that is provided to you in the exam. It's there in your notes, doesn't mean you have to memorize it. Okay, it is meant to use, not to memorize it. That is the very important thing. In fact, all the tests that you see here, even when we say multiple regression, assumptions, violations, in that under the violation also the Brosh-Pagan test or the Brosh-Godfrey test or DW test, you do not have to calculate. One test for multicollinearity, yes, for multicollinearity, VIF is various inflation factor that you have to test. So I will write down for multicollinearity, what is the test statistic? So test for multicollinearity. Okay. This is something that they may ask you to calculate. In this, we calculate something called VIF. VIF is variance inflation factor. Check out here, it's variance inflation factor, and this is based on r square. So it is 1 minus 1 over r square. So this is nothing but 1 minus 1 divided by, 1 minus r square. And simply to calculate this, you will just take 1 minus r square and inverse it. 1 minus r square and inverse it, and there are some levels of the r square. So if this r square, and based on that, what will be the VIF? That is something that you have to remember. Remember, r square maximum can be 100%, right? So the lower the r square, the lesser fit is the model. There is more chance of an error. So let's say we take the r square at 0.6, 0.8, and 0.9. In that case, if we calculate this, again, you don't have to calculate, but you should know the parameter here. So zero point 0.6 square minus 1, change the sign and inverse. You will get an answer. So we do zero point 0.6 square. If the r square, so this is r square already. Sorry, my mistake. So this is zero point 0.6 already, which is squared minus 1, and then you inverse, you will get, this is r square, then you will get this as 2.5, zero point 0.8 minus 1 inverse, this will be 5.9 minus 1 inverse, this will be 10. Now, as per the institute, when is this a concern? When will I say I will investigate for multicollinearity? If the number is 5 or more, we say it is worth investigating. You need to investigate for multicollinearity. But if the number is 10, it is severe multicollinearity. It is extreme, severe multicollinearity. So the number 5 and 10, you will have to remember. So VIF calculation and the numbers you have to remember. All right, everyone? Yes. Now, in the extensions of multiple regression, you have outliers, but outliers are for the independent variable, which is called leverage or high leverage, and for the dependent variable, we call it as outliers. So there is a two difference here. So there are two extreme values. So just for your reference, again, you don't have to memorize this formula, but if I were to find extreme values, so extreme value of x is independent, right? If you want to find what is the influential point, what is the when the observation is too extreme, right? That will create an issue with the model. So two things: high leverage, and the second thing is what we call as outlier. General word is outlier only, but actually both are outlier. High leverage is an outlier, is an extreme value of X, that is the independent factor, and outlier is an extreme value of Y, that is the dependent factor. All right. Now there is a formula for high leverage point, and when do we say it is influential? So our focus is influential point. Influential point means the point at which I will say it is too extreme. So that influential point we will calculate for X, that is the independent factor. For Y also we will calculate. So for Y, what is the influential point, the trigger point when I will say, oh, this is extreme. For X, the rule says that it should be 3 times of the average leverage. Average leverage. Now, what is the leverage? The leverage average is K plus 1 over N. K is the number of independent factors. So remember, I don't want you to memorize the formula, but in case if they ask you what is the leverage and the average of leverage, so we say average leverage and 3 times of it. So we multiply this with 3. Now the question is, what is the average leverage? Average leverage is dependent on what? The independent factors and the samples. So average leverage is K plus 1 over N. Yes, K plus 1 over M. So if it is 3 times, if it is greater than influential point, if this is greater, the average leverage is this. If the actual leverage, so I will rather write this. If the actual leverage, what is my inflation point? My inflation point, if my leverage point is greater than the 3 times of the average leverage, then we call it's influential. Influential means the outliers are extreme, right? For the outlier of x is extreme, which is called high leverage here. Outlier of y is just called outlier. In this case, we actually use a t-test. So we do the comparison of when do we say this is extreme? We say this is extreme when the t-test statistic is greater than the critical value. The t-test statistic. Now, the t-test statistics, again, this is very rarely tested, but I'm writing down the formula. This is about the error. So what we do when there is extreme outlier of y, are extreme. In level 1, we learned the two model replacement, that is called Winsorized, and trim. So here we do what? Trim. So we delete a residual, we delete a variable, and then we calculate the error. So we actually calculate error. Error is what? Error is y minus the predicted value of y, right? Or the expected value of y. So that difference between both is what we calculate. We call it as error. This error we calculate with and without the variable. So let's say if we exclude a variable, so with and without the variable, when we calculate the error, we do the standard deviation of it. So yes, we calculate the error for, let's say, last 10 years, and then we calculate the standard deviation of that error also. So this is your test statistic. I have been teaching this and telling the student not so important because it is rarely tested. But why? Because the test statistics might be provided to you. If it is provided to you, all you need to remember is when do I say it is influential and when do I conclude influential for high leverage and when do I say it is influential for outlier. That is what you need to remember more than the test statistic. Got it, everyone? Right. You can check out this here, the deleted residual error and the standard deviation of that error, which is called standardized residual, the name. Okay, everyone. Now, there are models, the extension, we are doing extension of multiple regression. And then there is a model which is dummy variable. Very important for your exam. This is multiple regression with qualitative independent variable. Independent variable when it is qualitative. This case, the outcome is binary in nature. So means either of the independent variable, its outcome is binary in nature. So binary in nature means now this, I will put up the formula here, which you should understand how it is utilized in exams. So let's say we will use now the model is called dummy variable. Dummy variable. So whenever you see a dummy variable in the model, actually it is multiple regression model only, a simple multiple regression model only. Only the outcome of the independent variable x can be your dummy. Dummy means it is binary in nature. So a normal formula, let's say a simple, I will do a linear regression y0 equals to b0 plus b1x. This is our model, excluding the error. You can also put the error for formality. Here, either of the thing can be dummy. So you will see the dummy variable. Now, let's assume that the x here is dummy. So when I say x here is dummy variable means we will only take the outcome of the variable either as 1 or 0. So x will be either 1 or x will be 0. Now, in the notes, we have done the comparison that what if the intercept is dummy, what if the slope is dummy, right? And what if both are dummy? In that case, what should we do? No need to worry about it. You don't have to memorize all of that. Just remember that in your this equation, let's say in your this equation, which we've used here for 3/4, just remember that if there is a variable which is dummy, you will take the value 1 if it is expected to happen and 0 if it is not. Expected to happen 1 and 0 if it is not. All right, everyone? Clear? Now, When we did cons, there are several other formulas. For example, for logistic transformation, which is called the logic test. This is when the dependent variable is dummy. Dependent variable, that is the y, when it is dummy, those models are called logistic or logit models. Now, even though here is the concept of formula for probabilities, how to do the odds and odds, this is something that we used to have before in level one. Now we don't have that. We used to convert the odds into probability and probability into odds. Now that is no more needed here. This formula, I've put it for a reference. My general suggestion is don't get involved into the formula. It is way too complex to understand and rarely tested. But still, if you want to understand the logistic transformation formula for your reference, I don't expect this to be tested because in the exam, they will generally provide you with the model and you will have to understand where the dummy variable is used. So this formula, you only do it if you have time. I otherwise don't recommend this formula to be done. Basically, it's a very lengthy process of converting odds to probability and probability to odds. In the class, I tell students, don't do it if you are not, if you are struggling with cons, don't do it. Otherwise, you can understand the concept and go in detail. But mostly this situation may not arrive. I cannot say it officially, but it shouldn't arrive. That is what we hope. What you need to remember that the logic model has dependent variable which is dummy or binary in nature, which is generally used to find the probability whether the situation will happen or not, whether the bond will default or not. So it is used for that. But if I'm using, if I want to understand that the dummy independent variable, in that case, we call it as dummy variable only, and that dummy variable is only for independent. Here it is in the case of dependent variable. My suggestion, no need to understand the formula, but if you want to read it, nothing wrong with that. Okay. So these are the only formulas that you should know. Dummy variable, high leverage outlier also, I don't recommend it, but still. VIF, yes, very crucial. You should know the model. What goes into the nested model, whether are we taking OR variable, it's a full model. Otherwise, it's a restricted model. Adjusted R square formula not needed, but you should know the adjusted R square higher is better. AIC, BIC lower are better, right? And of course, the R square formula that we all know. There are several concepts which are not enough just by analyzing the formula, but we have covered that in the quants. So quants is more than formula. Yes, some formulas are critical. About the test statistics, I have put up these formulas that you will analyze for test statistics. The other formulas are your choice. If you want to remember, I generally do not recommend. All right. Let's go with reading two, that is linear and log linear model. This model or this entire reading is time series. In time series, we will start with linear, log linear models, and then we will go to my favorite, that is autoregressive model, normal autoregressive, and then autoregressive with seasonality and arc model. So again, we are doing regression, right? So linear and log linear. What is the linear equation? What is the linear model equation? And what is the log linear model equation? Yes, linear and log linear. We use single factor model to analyze it. So we use phi equals to b0 plus b1 into x. But here the x is what? The x is what? Time. Time. The x is the time here. Are you with me? Plus error. This is the time series model. So the error is also for the time. So the biggest difference between a normal model and a linear trend model is that it's based on time. So time can be any period, right? This is what the model is. Log linear model, in that we use the log, but first we derive the exponential value. So what will happen in the log linear model? Again, log linear model, we will use the exponential of this. So the entire component will go into the exponential b0 plus b1 time plus error, right? So you can skip the error discussion here. So b0 plus b1 into t, that will be your log linear model. But it is transformed. We transform the log linear model so that we can utilize it we can utilize to derive a value. So how do we transform it? We take the log on both sides. So then the log natural of t is the time, will become log of e to the power x will become x. So this will become b0 plus b1 into t. Understood, everyone? These two models, linear and log linear models, linear and log linear models, the problem with these models is that they have autocorrelation. So for this, we use a Durbin-Watson test. So we have a problem here of autocorrelation, for which we use a DW test. DW test. Okay, just for your reference. All right. This is a linear and log linear trend models. The more important is the AR models, auto regressive models. So we will understand AR model and AR with different lags, AR1, AR2 models. So AR model is what they are dependent, the value here, the value that we are going to derive is based on independent factor, but we are also trying to derive the value of that independent factor itself. So what is the difference between a normal time series model and autoregressive model? ER is also a part of time series model, but it is the current value of X dependent on the past value of X. So a typical AR model, we will call AR1. Typical AR model is called AR1. It is does the model signify? It gives me the value of X today is based on b0 plus b1 into the value of x in the past. So this is t and this is t minus 1. Okay, I'm just ignoring the error here. This is my AR1. But what will be AR2, where I will regress the values based on two lag values. So I will go 2 period in the past. So AR2 will be like the value of x is based on b0 plus b1 x, and then we will introduce b2 also plus b2x. Now what is the difference here? If this I want to find t, this will be t minus 1 and this will be t minus 2. This is 2 period back. Is everyone understanding this? How do we do 2 period back? So this is AR2. Likewise, we can do AR3, AR4, but maximum you should know AR1 and AR2 only. AR1 and AR2 only. Now, before discussing the rest of the things, what if there is AR with a seasonal lag? If I put AR with seasonal lag, very important. Okay, AR with seasonal lag. How does the model look like? AR with seasonal lag, if you notice here, we will again derive the value of x equals to b0 plus b1 x, which will be there, right? b1 x. Until now, everything is okay. But then I will add a seasonal lag. This is what we call BS. This season can be last year, same quarter, or it can be any other quarter. So we quarter, if it is monthly, it can be last year same month. All right, so we will do this b and x also with a seasonal lag. So when I use the seasonal lag, we say a specific season. That season we as of now don't know, but it's the past, right? It can be a quarterly. If it's quarterly, it's 4 lag. Monthly, it is 12 months back. So we use that TS or T minus S, you can say. So this is where we use a seasonal lag. So in this case, we will use T minus S, how far it is. So if a seasonal lag is quarterly, it's 4 quarters back. If it's monthly, let's say 12 months, so it's 12 months back. All right. This is AR1 or AR2, everyone in the class? This is AR1 only. One only, because I'm going one period back, and this is not called AR2. This is called AR with a seasonal lag. Are you understanding the difference? AR1, AR2, and seasonal lag. Everyone clear with this? All right. Yes. Autoregressive model, in this case, we do autocorrelation test for which we do a t-test. So we do a t-test, and even though, again, I will repeat, you do not need to memorize the test statistic, but for AR test, it's a systematic process where you calculate the autocorrelation of, let's say there are two securities, you calculate their correlation, and that correlation you calculate, that correlation between security 1 and 2, here that 1 and 2 is nothing but the variables. So here the variables that we are testing, whether there is a high correlation amongst them or not, the time period. So that is what we will be testing. Therefore, we divided by what? We divided by the inverse of time root. Remember, correlation does not have a unit. So we do the root of time. I will repeat, this statistics may not be needed. This statistics may not be needed. So this is called standard error adjustment in the denominator, but it may not be needed. Okay. This statistic is nothing but the t-test. T-test is used for autocorrelation. Now, there is a concept called covariance stationarity, where the mean, the variance, and the covariance should be constant, stationary, right? For this, the one which is very important is the mean. The mean has to be stationary, which we call as mean reverting level. Very important for your exam. Mean reverting level. Mean reverting level helps you understand whether the variable will increase or decrease. Mean reverting level is very, very crucial. It is simply B0 over 1 minus B1. 1 minus B1. So it is based on the variables. So this will tell me what should be the value of X that we are trying to get. This should be the mean reverting level. If the actual value of X is way higher than this, then it will fall. If the actual value of X is lower than this, then the value will increase. This is called the mean reverting level. Understood, everyone? Mean reverting level, mean reverting level. Yes. Okay. Now, in the concepts, where is it? We will go to the concepts. In the concepts, we had something called in-sample forecast. So we calculate the forecasting error. We've already done this error. And out of the sample forecasting error. So again, we calculate the error, but there is a formula which we want it to be lower, that is RMSE, root mean squared error. You may not require the formula, but this is nothing but the error standard deviation, the standard deviation of the error. So what is RMSE? Root mean square error. So when we calculate the difference between y and the forecasted, right, that error standard deviation, how do we calculate that standard deviation? Summation divided by n. For sample we do n minus 1, and then the root of it. So basically this is the standard deviation of the error, that is called RMSE. We want out of the sample RMSE, standard deviation, to be lower. Out of the sample, lower RMSE. Then we say the model is best, or it is better for forecasting. All right. Now, there is a very interesting concept called random walk. Random walk. And then under the random walk, you have random walk, a basic random walk, and you have random walk with drift. With drift. Two things, random walk and random walk with drift, and both have a problem which is called unit root problem. Unit root problem. What is unit root? We will discuss. And because of the unit root, what is the solution for that problem? That solution for that problem is called first differencing. First differencing. Okay. So we will understand all one by one. What is random walk? What is random walk with drift? The problem of unit root, and what is first differencing. So what is random walk? Random walk, first of all, in the normal regression that you know, in that, what is a regression model, everyone? Xt is equal to b0 plus b1, and then xt minus 1, right? Xt minus 1 plus the error, plus the error. All right. Now remember, in this case, random walk means the value of xt just follows random walk. Means here, if you keep the b0 and b1, if you do the value of b0 and b1, where b0, if we keep b0 and b1 as some amount, if we keep a fixed amount, we'll get the value. But what if I keep b0 as 0 and if I keep b1 as 1? In that case, my model will transform into, yes, any guesses? It will become xt will become b0 is 0. So it will be simply xt minus 1 plus error. Are you noticing this? So the difference between current and past value is just random. That is the error. Understood? So error here is nothing but the difference between current value and the past value, or the current value and the future value, is random. That is why it's called random walk. Now the same concept, when I use it for random walk with drift, in that case, we do a minor change, is that here, take it down. What changes? What changes? In this case, first thing, what will change if I change here, and because of which the equation will change? We do not assume the b0 as 0. We do not assume b0 as 0. That means the b0 will be there. So b0 will not be ignored. So then it will be b0 plus random amount. Okay, so the difference between past and present will be r- random, that is error, plus the intercept. That is called random walk with drift. That b0 here is the drift. Both have a problem, that both are covariant stationary. No, they are not covariant stationary. Why so? Because for covariant stationary, there should be a mean reverting level, and here mean reverting level is 1 b0. So it is 0, which is over 1 minus b1. Remember, b0 is your or mean reverting level, which we just calculated. Mean reverting level b0, 1 minus b1. So if I do 1 minus b1 here, so 0 over 0, if you do 0 over 0, you can check it, you will get error. Anything which gets error is not covariance stationary. Anything which gives you error. Now check it out for this also. So here also, even if it is not 0, let's say if it is some amount 1, so still anything divided by 0, even if you do 1 divided by 0, it will give you error. So the problem is B1. That's the problem. That is called unit root problem. B1 as 1 is a problem. So unit root problem is nothing but your B1, that is the slope, is equal to 1, which makes it covariance non-stationary. That is called the unit root problem. So the solution here is first differencing. First differencing means what? We take the difference between the values. So the change in x for the time is nothing but the difference in the value. So we take the value in the current period and we separate it with the value in the past, t minus 1. That's the solution. So when we take the first difference, we are assuming in that case, what is the assumption? The problem was b1 equals to 1. That was the problem with this model. So now we do what? We test and we bring the solution here. Is that very interesting? So here in this case, the model is now transformed, because if we take both 0, if we take b0 also as 0 and b1 also as 0, so then my mean reverting level will be 0 divided by 1, and 0 divided by 1 minus 0, that is 0. So now this becomes stationary. Understood, everyone? Random walk without drift. Everyone, what is the solution for it? Clear, clear, clear. First differencing. All right. We already did AR with a seasonal lag. Guys, you just want to understand, go through it. It's also in the notes, by the way. All right. Now, the last thing in the model of time series was arc. Arc. Arc is also a time series model. Until now, in the time series, we derived the value of x based on the past. Now, what if I want to analyze the variance of the error? So when we are doing ARC model, what is the full form of ARC? Autoregressive conditional heteroscedasticity. So it's extension of AR model, but conditional heteroscedasticity means we are testing the variance of the residual. So let's say error variance of the current period is based on the past period. So we will do the same. Instead of B0, we write A0, and instead of B1, we write A1 multiplied with the error variance of past. We do past, that is t minus 1, and the error in the variance here, we also add an error extra, but that is the hypothesized value. So you can skip that. Just remember this is used for forecasting the error. For forecasting the error. Now this can also be extended. All the AR models can be extended for the next period. So if I want to do error t plus 1, I will do A0 plus A1 into error t. So this can be used for forecasting future. The more in depth you go, the higher will be the uncertainty with the model. Okay. These are all the formulas that you need for time series or overall quants. Quants has all the formulas in this section. Machine learning, big data, no need to do any formula. There are a lot more details in the quants. I'm not telling you that, don't misinterpret the formula session with the revision and this is enough. No, this is just that at the last moment, I should not get stuck into what is the formula, what is the condition here, right? I generally tell students, if you have time, you should what do your notes and also make the test. You can compare all the tests. So we in the notes, we have something at the end. We write all these things we've written in the class. We took around more than 125, 130 hours of session in the full course and another 50, 60 hours in the revision. So we wrote down which test is used for what. That is in the revision book. Here, from the understanding point of your formula, yes, the quants formula all at one place. Cool, everyone? Got it? Yes. Any doubts, any questions? Yes. All right. We are starting with the topic of portfolio management. 10 to 15% weightage it has, and this 6 reading has too many formulas. Okay. Many of these formulas are slightly related to cons because they are based on returns, multi-factor returns, but to a larger extent, portfolio is not that easy. First topic, we'll start with economics and investment markets. Let us start with the first reading. In this topic also, there are too many formulas. One is intertemporal rate of substitution. One formula is called intertemporal rate of substitution. That is the name of the concept, and that rate is intertemporal rate is called MT. We use it for a reference. It is a ratio of the utility. So the ratio here is of what? It basically tells you that the utility or marginal utility, to be precise, of consuming in the future divide by consuming today. That is current. We are comparing what? Future consumption and current consumption. So that is U utility. T is for next period and 0 is current period. And like present value, the present like the time value, present value has more value than the future value. So this ratio is generally always less than 1. And why is that so? Because current consumption or the utility of current consumption is always greater than the future consumption, and therefore we conclude that MT should always be less than 1. Information is necessary. This information is necessary in case if something tested up in exam similar to this. This MT is also used as a reference for calculating risk-free rate. Yes. What is the use of it? We are going to calculate risk-free rate. So to calculate risk-free rate, if they give you this intertemporal rate of substitution, then what we just need to do is that we need to take the inverse of this expected marginal utility function or marginal rate of substitution. We just take inverse of it and subtract 1 from it. This will give me risk-free rate. Remember, this is how we calculate risk-free rate. And here, the risk-free rate is nothing but it is same as inverse of price minus 1. That is like a zero coupon bond. In zero coupon bond, you will get par value on maturity. So how do we calculate return? F ending over beginning value, right? So it is similar to ending value, par value, that is 1 over the beginning value, that is P0 minus 1. So it's the same thing. And therefore, this is how we derive the risk-free rate. This becomes a bit confusing for students. So just remember here the expected marginal utility is nothing but the intrinsic value that you remember as of now. So in case if they ask me in exam to calculate risk-free rate, and if they give you utility, just take inverse of it. Let's say the utility is 0.95. So I will take 0.95, inverse it minus 1. I will get 5.26 percentage. 0.95 is like $95 bond. So if you take a bond whose par value is 100 divided by 95 minus 1, you will get 5.26 percentage. So here, if I tell you that what is the value, if they give you this as 0.95, you will get the risk-free as 5.26 percentage. You can calculate it. Understood, everyone? Right? The ratio will be always less than 1. So it is used to derive the risk-free rate. Throughout the syllabus, you will see the risk-free rate. That is the basic thing. And then we utilize it to derive the value of the bond for a bond which is risk-free to a risky bond. So where is this used? To derive the value of the bond. So let's say if I want to find the present value of a bond or the value of a bond, which is first we will derive it for a risk-free bond and then a risky bond. So what is the difference in the formula? Risk-free bond, and then a risky bond. Please write down this because it is scattered in the concept, in the notes, it is a bit scattered. So here we do what? We are trying to find the intrinsic value, that is the P0 or V0, whatever you call it. That is a value today. It is based on these are zero coupon bonds. So it is based on expected price after 1 year, expected price after 1 year, and then we discount them. Remember, in fixed income we discount that with the spot rate. That is nothing but the risk-free rate. So we discount them with the 1 plus R. Now that you will notice is common under both for a risky bond and a risk-free bond. But a risky bond's value is higher or risk-free bond's value is higher. Always remember, a bond's value is higher or risk-free bond's value is higher. Yes, a risk-free bonds value is higher. So this, along with this, we add what? We add the covariance. We add the covariance between the bond and the factor, the marginal utility factor. That covariance between the bond and the utility is expected to be negative. So we add the covariance of the bond, everyone in the class, and the marginal utility. This component is expected to be negative. Remember, a bond which is uncertain, in that case, the covariance, that is a risk premium, you can consider it like a risk premium, that is generally negative. So because of this, what will happen? The risky bonds value will be lower than risk-free bond. So all this drama was to derive the risk-free rate, that is R. Are you with me? It becomes confusing and messed up. So now you can relate what marginal utility will help you derive the risk-free rate. Risk-free rate will help you derive the present value of the bond, risky bond and risk-free bond. Risky bonds value will be lower because of the negative relation between the price of the bond and the utility. That is the risk premium. You can term it like a risk premium. All right. In exam, just remember, if they give you utility, inverse it, -1 is your rate. I'll repeat, for your exam, take the inverse of it, -1, and subtract -1. That is your risk-free rate. In the exam, the risk-free rate is important. All other formulas in this reading are related to risk-free rate, because once you get the risk-free rate, after that you have short-term and long-term nominal risk-free rates. Nominal risk-free rates. Nominal risk-free rate. Now, between short-term and long-term. Now, remember, nominal risk-free rate is based on Fisher effect. Fisher effect. Fisher effect is what? Real risk-free rate. Real risk-free rate plus we write expected inflation. So expected inflation we denoted by this. Okay, everyone. This pi value, or you can say any value. This is your expected inflation. I will write down. This is my expected inflation. And this is my real risk-free rate. All right. So real risk-free rate plus expected inflation. That is common for short-term and long-term nominal rate. But long-term will have one more thing extra, and that is called theta. That is, the longer the maturity, the more the uncertainty. So uncertainty about what? Uncertainty in the inflation. So we have two inflation. One is the expected inflation, and then second is called the unexpected inflation. So this is called the unexpected inflation. You can write it for your reference. This is unexpected inflation or uncertainty in the inflation. This is the difference between short-term and long-term nominal risk-free rates. Likewise, what we do, I will summarize all. We will do what? Oops, sorry. Likewise, we will do what? We will keep on adjusting some premiums. So there are several premiums in the notes. Also, I've adjusted that. From bonds, we then move to these are all risk-free bonds. So then we move to the risky bonds. What is the required return on risky bond? Then much riskier is equities. Then we go for equities, and then we go for real estate. real estate. This is the order that you will, in this order, you will understand the components, because as it goes ahead, the components keeps adding. So here it will be real risk-free plus expected inflation, real risk-free plus expected inflation. This is always there. Real risk-free plus expected inflation. In the risky bond, we have the uncertainty about inflation, but we also have something extra. So now I will add the uncertainty of inflation. But what is that extra? That extra is the credit risk. Remember, risk-free and risky bond, the difference between both is the credit risk. So this you can use it for your reference as credit risk or spread. Spread is the difference, right? So that spread is the factor here. So that extra factor that you see is for the spread. Now, everyone in the class, understand this. Compared to this with equity, equity will also have the similar components. Equity is also having all the risk, and real estate will also have all these risks. So the uncertainty in inflation that you see here, that will always be there. Okay. But now, when it comes to equity, equity has risk higher than the bond. So, in case of equity, we will have the risk, credit risk, but that extra risk over the bond, that additional risk over the bond, you can denote it by any factor in the class. We've denoted them with the factor I will mention. There are some Greek letters we use it. You can ignore the factors and you can just write it also. You will see something similar to the Greek letters here. So that is the extra risk, or I would say additional risk due to equity. That is the extra risk of equity. Extra risk of equities, or you can say equity risk premium. All right. Along with this, in real estate, there is one more component. So along with this, the real estate has one problem, that it is difficult to sell. So in real estate, we add the liquidity risk premium also. So we add the liquidity risk premium. So what is this? In real estate, this is liquidity risk premium, or premium for illiquidity. All right. Here, remember the common component here, everyone, this inflation, expected and unexpected. This expected and unexpected inflation also has a name throughout. You will notice this name, everyone. This is also called bonds break-even interest. So you will see the break-even inflation or the break-even interest here is nothing but the difference in the two bonds inflation. So that is your break-even inflation, which is nothing but inflation certain and uncertain. So that is also called your break-even inflation. Now, in reality, break-even inflation can be derived using two ways. We will write down both. We'll add break-even inflation is nothing but expected inflation and unexpected inflation, but it is also derived as the yield on two different bonds, and both are actually treasury bonds. So when we take the treasury bonds, remember, in treasury bonds are risk free. Treasury bonds are risk free. Treasury bonds do not have a risk. But in this treasury bonds, what are the two types of treasury bonds we can take? One is that we take a nominal, and then we take an indexed bond, which is inflation index bond. So if I take the yield on a nominal bond and inflation index bond. Now, when you take the difference between these two bonds, the only difference is due to the nominal bond already has inflation, expected inflation, but inflation index bond, nominal bond has all the inflation, by the way. Inflation index bond will be without inflation. So the difference between the two bond is nothing but your break-even inflation. So that extra yield that is due to what? That extra yield is due to the uncertainty and certainty about inflation. So expected and unexpected inflation. This is your break-even inflation. In this topic, there is a high chance that this is testable. This as well as all the short-term rates, highly testable. But the most testable according to me is the Taylor rule. You must have seen you must have seen a lot of questions by now when you're analyzing the formula, and you must have encountered about the Taylor rule. Taylor rule is very critical. Taylor rule takes the perfect combination of inflation and GDP, and this is how the central bank decides on the rate. So the rate decided by the central bank, that is called the policy rate. So here R, which is the policy rate, and how do they decide? That policy rate that they decide is based on, of course, inflation, because monetary policy's broader objective is not only to control inflation but also look at the growth. So both factors will be taken into consideration. So we take first is the nominal risk-free rate, which is nothing but the neutral rate. So we first take the neutral or nominal neutral rate. Now, when I say nominal neutral rate, it is a combination of two things: real neutral rate and current inflation. Yes, it is real neutral rate, and I will explain you what is real neutral rate, plus current inflation, the existing inflation. Now, central bank wants to maintain the economy at this rate. The real neutral interest rate is nothing but the real rate in the economy. Real, you can assume real GDP growth rate that the central bank wants to maintain. So the nominal neutral rate is adjusted for the unexpected changes or the surprises in the inflation and the GDP. So what is the change in the inflation? That is what we will consider, that central banks have a targeted inflation and target output that they want to achieve. So how much is the difference between current and targeted inflation? Current inflation and targeted inflation. So let's say current inflation and targeted inflation. This is, I will write star mark, this is targeted inflation. So the difference between these two, and for GDP is in dollar, right? So we want to convert the GDP, that GDP difference. So GDP also based on what is the current level to the expected or potential level. Okay, so we say GDP Y minus the current level minus the potential. All right. GDP, we always take in log. Why do we take log? We have to transform it. Okay, so this is the of log of GDP or output, log of output, and here this is current and this is potential. This is potential. This is current and this is expected. So here this star is nothing but, I will write down expected. And this is potential GDP. Potential is similar to expected only, the star mark that you see. But how much weight should I give for both? So we do equal weight. So 50% to this and 50% to this. So if the current inflation is more, if the current inflation is more than the target, the rate will increase. If the current GDP is more than the potential, the interest rates will be increased by the central bank. Taylor rule, very, very, very important. Understood? Taylor rule, Taylor rule. Where is the Taylor rule? Very, very important. Why do we take the log value to transform the model? Because everything is in percentage. So the GDP also should be in the log. All right. All right. These are the important formulas for your reading one. Reading one looks very simple, but trust me, it has too many formulas. All right. My suggestion would be remember Taylor rule and the difference between short term, long term risky bond to equity, equity to real estate. How the risk premium keeps adding up. All right. Everyone till this point? Yes. Now let us move to reading number two. Reading number two focuses on one aspect, that is active portfolio management. This is where there are too many formulas. Okay, which formula is essential, not essential? When we were revising reading number two, we actually wrote down a lot of formulas. So the three most important formula, in fact, two only, but very important for your exam, even though they're very simple, is here we are going to decompose active return into asset allocation and security selection. So active returns and active risk, that is what will be our focus. Active return is nothing but the difference between what the portfolio and the benchmark return is. Remember, active return, active, how much is extra? So we always take the difference between the portfolio and the benchmark return. That is what my active return is. This active return can be broken down into two components. One is allocation, and then there is selection, security selection. So we say asset allocation returns and then security selection returns. Okay, so we will break down into two returns, asset allocation and security selection returns. Now this is going to decompose your returns. You will have to understand how much came from changing the weights. So weight of security in the portfolio minus weight in the benchmark into the returns of the benchmark. Into the returns of the benchmark. Yes, we multiply that with the returns of the benchmark. This helps us understand that how much was the return due to just the allocation of the weights. So we will of course do the sum of all depending on how much is the difference in weight. Remember, the difference in weight is called active weights or active asset allocation. So active weight is the difference in the weight between the portfolio and the benchmark. That is called as active weights. Active weights. I'll repeat, the difference in this weight has a name. This is called active weights. All right. This active weights multiplied with the benchmark return will give me asset allocation returns. So this is my asset allocation returns. Security selection return, and this is again for depending on all the securities or all the asset class in your portfolio. So I did the summation. Security selection return is return of the portfolio and the benchmark, the difference between both multiplied with the weight of the portfolio. Remember, multiply with the weight of the portfolio and the summation for it. All right. So it's like we are trying to find active return for each security. Okay. Together, asset allocation returns plus security selection returns, this together should match your active returns. If not, you've done something wrong. Is this clear, everyone? All right. Based on this, we have two ratios, especially the information ratio, which is the most critical. Information ratio is nothing but a ratio of active returns to active risk. Active risk is also called tracking error. Tracking error. So basically, active return is portfolio minus the benchmark returns and the standard deviation of the same. Standard deviation of portfolio minus the benchmark, that is nothing but my tracking error. This is my information ratio. Sharp ratio is pretty much similar to what you did in level 1. It is the excess return over the risk free. We don't take the benchmark here, over the risk free divided by the total risk. We don't take tracking error, we take the total risk of the portfolio. The most important for you here is the information ratio. Everyone with me on this? Clear? The difference? Active returns, asset allocation, security selection, information ratio. Trust me, there's a high chance of this being asked. There are a lot many formulas which are complicated, but this has the highest chance of being asked. All right. Now, the other formula which is critical is that we will break down the information ratio. That is called optimal information ratio. One of my favorite formulas, highly tested, I've been seeing that since many years, is this has a combination of three things: IC, TC, and breadth. Breadth is what? IC, TC, and breadth. Breadth is the number of securities or number of trades or number of bets. So because it is in quantity, we always use this as square root. Square root. So these are the components of your, this is also called the fundamental law. They are the components of your information ratio. So this is also called fundamental law or components of information ratio. Components of information ratio. This what we just did is called fundamental law or components of information ratio. Remember here we will discuss when we multiply all three, we will get optimal information ratio, or simply how the information ratio is broken down. Here, remember, IC is nothing but the correlation. Correlation, you don't have to calculate. Just I will write down the difference here so that you can relate the formula. IC is nothing but the correlation between the actual returns and the forecasted return. Let's say forecasted returns and actual returns of the manager or the analyst or the fund. This higher is better. TC is constraints. Constraints. TC is nothing but constraints. Constraints. And this constraints will be what? If the transfer coefficient is equal to 1. If the transfer coefficient is equal to 1, it is unconstrained. So if the TC, maximum the TC can be 1, or if it is less than 1, it is constrained. So this is constrained and this is unconstrained. So the maximum the TC can be is only 1. Breadth is the number of independent decision. So this PR is number of independent decision. Are you with me on this? Okay. Now this is number of decisions, number of independent decision to be precise. Independent decision, how many bets you took in a year. Now for the breadth, even though it is at the end, I will discuss what is to be adjusted for the breadth. The breadth can sometimes just randomly increase. So we do adjust the breadth, which is actually at the end of the part. But since we are now discussing everything, we can put the adjustment related to breadth also. So if you want to understand the adjusted breadth, I will write down the formula of adjusted breadth also. What is adjusted breadth? This is also you should remember together. Okay, adjusted breadth is what? The number of bets that you did divided by a complicated ratio, it might sound, but 1 plus n minus 1 into r. If this correlation is high, what will happen? The denominator will be high and the n will be low. As someone who wants to analyze the information ratio, you want the fund manager's IC to be high, TC to be high, and breadth also to be high. So this basically penalizes for common bets. This formula, has everyone understood this formula? Everyone? Very important. Okay. I've actually put the entire uh, information ratio component right in front of screen. This allocation difference between allocation security selection, highly testable, information ratio components, highly testable. All right. There are other formulas also, like which are focusing on the risk part. So we'll focus on the risk part. What is optimal risk? What is the ratio? We will see very important ratio. But before that, this is one of the most important formulas. All right, everyone. This is also called optimal information ratio. Perfect. Then there is a point called optimal active risk. Very important. Optimal active risk. Now, active risk is nothing but the standard deviation of active returns. Optimal active risk is sometimes denoted with a star mark. That is the optimum active risk. This is standard deviation which will maximize the Sharpe ratio. This formula, again, if you check our notes, you will see all of that. Yes, optimum active risk. This takes information ratio, Sharpe ratio with the benchmark. We had solved some of the VNets in our fast track revision where we saw questions where optimum active risk is tested. So here we take the information ratio of the fund and divide it by the Sharpe ratio of the benchmark and multiply with the standard deviation of the benchmark. Here we also take the standard deviation of the benchmark. Yes, in reality we also multiply with the transfer coefficient, but if it's an unconstrained portfolio, the transfer coefficient is always 1, so it actually gets ignored. Okay, so you can write it or you can skip it. If there is a transfer coefficient only, then you need it, otherwise you can skip it. This is called your optimum risky asset. Optimum error, optimum error, or optimum active returns. Everyone, correct? So tracking, oh, it's my mistake. Optimum active risk. That is a tracking error. So this is the risk point at which Sharpe ratio will maximize. Now, always remember the systematic and unsystematic risk. So here, total risk. First of all, let us define before we only focus on the tracking risk here. The portfolio risk, total portfolio risk is now active and passive both. So if I want to calculate the total portfolio risk, remember always risk is always calculated in terms of square. So there are two risks here, active and passive, like a core satellite. So we take the risk of the benchmark and then there is the active risk, how much you deviate from the benchmark. So it is called the benchmark risk plus the active risk plus the active risk. So total risk is benchmark plus active risk. And what is the optimum active risk? Optimum active risk. At this optimum active risk, how much should be the expected return? So remember what is information ratio? Information ratio is, if I use this ratio for forecasting, instead of saying active returns, I will say expected active return, and in the denominator I will use the optimum risk. Yes, so if I use standard deviation of A, that is the optimum risk. So at this optimum level of risk, how much is the returns that I should expect? So this formula is used to derive expected active return is information ratio into the optimum risk. Very, very important. Okay, this concept is very important. This helps you forecast how much expected return I should expect from my portfolio. All right, everyone. Understood? You can always break down information ratio into IC, TC, and breadth. Breadth always take the square root. Breadth always take the square root. All right. Yes, check out this. All the formulas. Everyone, check out this. Yes, We had solved all these formulas. We had written down while we were revising also. One formula is about the proportion of active and benchmark risk. So out of your total risk that you have, out of that total risk, how much is the proportion of active and benchmark risk? So this formula is just to find the proportion. You may not be expected to be tested in exam, but in case if they test that how much of your how much of your total risk is due to active and due to benchmark, you will just take a proportion of it. If your proportion of active risk is 40%, the remaining will be from the benchmark. So it's just that we calculated the ratios, we calculated the risk. If they ask you proportion, just take this divided by the total, this divided by total. That is your proportion of the risk. Out of the total risk, how much is active and how much is passive. Remember, if it's a constrained portfolio, the TC will be less than 1. So all the formulas with constraint will have TC. If there is no constraint, there is no TC because the answer is 1 only. All right. The most important aspect is that this formula is used to derive the expected active returns. Because if I want to find how much should be my portfolio returns is benchmark return plus expected active return. So you see how this is connected. This is connected, how this is connected. So optimum risk, on that I will get what should be at that optimum risk, what should be my expected return, and that expected return plus the benchmark return is my portfolio return. Similarly, active risk plus benchmark risk is my portfolio risk. So now you can break down the portfolio return and portfolio risk in terms of active and benchmark. Yes, which one, dear? Which one do you want me to repeat? Yes. So you notice here, I have broken down my portfolio return into active and benchmark, and portfolio risk into active and benchmark risk. Yes, understood this all? Yes, any question? Yes, please tell me. What is the question? Yes. Check, check, check. Optimum active risk, very important formula, right? And breaking down of the risk and then breaking down of the returns. Your end goal is how much of my return is active and benchmark return. Clear, everyone? Yes. There are a couple of concepts here which are a bit extra. Just remember, yes, I think there is some doubt, right? What is the doubt? As I mentioned, if there is transfer coefficient will only appear if there is some constraint. If there is no constraint, TC is always equal to 1. TC is always equal to 1. Just remember that. Okay. Yes. Any questions? There is one formula which is about understanding the IC. Sometimes, IC is the correlation between the actual and forecasted. Now, what if the analyst is half of the time correct? So it may not really be an information coefficient. So to understand the IC in terms of, how we adjust the IC for market timing. So we concluded what was IC, information coefficient. You can add it there itself, that what if this has to be adjusted for market timing. So if I want to find IC adjusted for market timing, adjusted for market timing of the analyst. So analyst can be 50% right. If 50% right, IC really doesn't make sense. Why? Because we take 2 into percentage of correct bet. Percentage of correct bets. Like, so how many times you were correct? If you were correct 50%, this will be 1 and minus 1. So this is 2 into percentage of correct minus 1. That is your ratio. So this makes sure that you have to be correct at least more than 50%. Otherwise the answer will be zero. So the real IC will only appear if you are more than 50% correct. Is this clear? Yes. Any doubts? Any questions? Wow. So all the information ratio components and the adjustment to breadth, IC, TC, everything on this page or everything at this point. Clear, everyone? Remember all the ratio when it's an unconstrained, TC is 1. So whether you put up in the formula or if you don't put up, doesn't make a big difference. This topic has one of the highest formulas. All good? Yes. Please note down these formulas, all the active return and all. Now, actually, there are many of these formulas which are repeated when we do the multi-factor models. In between, there is a formula section for ETFs, exchange traded funds. In exchange traded fund as such, there are not too many formulas because most of the formulas are related to tracking error only. However, there is one component about what is the ETF spread. What is ETF spread related to? ETF spread. Remember, the market maker or the dealer here will charge a spread. This ETF spread, let me walk you through that in the notes where it is so you can relate it. Everyone, where is it? Where is it? Yes, see, this is what the market maker will charge us. So he will charge for several fees. All of these fees are added. Only one thing is subtracted is the discount if offsetting is likely in the secondary market, means if he can make some gains there. So I don't expect this to be memorized, but still, ETF spread. What is the cause that the spread increases? There are several fees charged by the market maker. That is the creation and redemption fees. So, creation and redemption fees. This will increase the spread, right? Most of the components will increase the spread except one. So, the spread will be wider. If the underlying security, remember ETF is invested in the underlying security. So the spread of those underlying securities or stocks, underlying securities or stocks or bonds where the ETF is invested, even properties, if that is higher, the spread will increase. So ETF spread increase due to, due to, or this spread will increase due to what? All of this factor: creation, redemption fees, underlying asset. Then they hold the security. So there is a cost of carry, which is called risk premium for holding inventory, and AP margin that they have to give. So cost of holding the security, which is called risk premium of holding the assets or holding the inventory, because inventory might lose in value. Holding inventory. And the authorized participant margin. So they have to cover up for the margin charged by the authorized participant. Authorized participant does want to make some profit and then he passes on to the market maker. The only thing that that will cause your spreads to be lower is if there is any offsetting that the market maker makes. So there is a discount. There's a discount on, if you want to learn the full word, it is discount if offsetting trade is likely in the secondary market. If offsetting trade in secondary market. This is the only component which will reduce your spread. Now, here, remember that the market maker can do an arbitrage also. So all of this will reduce my cost. All right. ETF, we had already done a formula of how to calculate the premium discount for ETF, like REITs, same way. If I want to find the premium discount in percentage, especially, we will compare the exchange price and the NAV. So the ETF price or the exchange price, how much it is above or below the NAV. So if it is higher than NAV, we call it as premium. If it is lower than NAV, we call it as discount, and we can convert this into percentage also. Everything is in per share, okay? So ETF price minus NAV over NAV, that will give you percentage discount or premium. This is all common. The most important formula for your exam year from this topic is the cost of ETF. Yes. So what is the cost of ETF? Cost of ETF. Very important. So basically it is when you invest in ETF, the total cost that you will pay, and ETFs are sold on exchange. So there is a cost which is called round tripping cost. Yes. What is it called? Round tripping cost. And the second component is the fee that you will pay based on some percentage of the value that of your fund, that is called the management fees. Management fees, because it's a fund. Now remember, what is a round tripping cost? Round tripping cost is basically for buying and selling the ETF on the exchange. So this round tripping cost actually has two components. One is the bid ask spread, yes, which will be provided to you, bid ask spread in basis point. But the second is related to commission. Now they will give you commission or brokerage, but always multiply this commission with 2. And why is that so? One for buying, one for selling. So together, commission into 2 plus bid ask spread is your round tripping cost. Management fee, make sure that whatever is the management fee is always annualized. So you will have to break it down for the month or the days that you are holding up. For example, if it is months, I will write months divided by how many months? 12. So whatever months you have, divided by 12. For example, if you're holding the ETF, or if you have held the ETF for 3 months, so you will have to multiply the management fees, which are always annualized, into 3 by 12. Are you with me on this? This is the only important formula in the ETF. This spread, even if you don't remember, it's okay. But cost of ETF, yes. This is very crucial. Understood? This is the only formula that you should focus in terms of this reading number 3 of ETF. Reading number 4 is where you will see the relation with the multiple regression, because the topic here is different types of models. In level 2, we do multi-factor model. The most common model that you will see here is about APT, which is an extension of CAPM. APT is a multi-factor model. So two models, multi-factor models, APT we will learn, and then we will learn a macroeconomic factor model and fundamental factor model. So three models: APT model, macroeconomic model, right? APT, macroeconomic factor model, and fundamental factor model. Fundamental factor model, macroeconomic factor model only, and APT model. All three are used to derive expected returns based on something. So what are these expected return and what is the difference? I'm writing all the three models so you understand If in exam, if they ask you what is APT model, based on APT model, derive expected return. So we are deriving the expected return on the portfolio. This expected return on the portfolio is equal to what? APT multi-factor. So it's risk-free plus beta 1 into, we say, risk premium 1. It can be any factor plus beta 2 into risk premium 2 and so on, right? So it can keep going on and on. This is a typical arbitrage pricing theory. So in exam, even a pharma French is a multi-factor model. So here what we do is that we keep on adding. So all the factors that are provided to you, multiply that with its risk premium and add the risk free. That is your typical APT model. So factor risk premium into factor beta. This is called factor risk premium and factor beta, or simply the factors. Okay, so you can add as many factor as possible. Macroeconomic factor model has a unique thing. In that case, we derive the expected return without surprise. This is return without surprise. If there is no surprise, how much is the returns? That is your expected return. Sorry, my mistake. This is going to be my expected return. Macroeconomic factor return has expected returns. Now, very important model. Even before I start the model, why is this expected return important? Because generally in all the model, we derive the expected returns. Here in the macroeconomic fundamental model, the intercept which in APT model is risk free, here the intercept is expected return. So if the intercept is without surprise, remember B0 is the value when all other are zero. So this will give me the return on my stock or the return on the portfolio, but that return will be now a combination of what? That return on my portfolio will be a combination if surprise and if no surprise. So let's say here I put I can be a portfolio or stock. So now, very important, macroeconomic factor model does help me derive not expected return, but it helps me derive return assuming no surprise and with surprise. So surprise can be multi-factor. The two factors that we discussed in the class or in the notes are the factors in the macroeconomic factors. Now, what are the macroeconomic factors? The GDP, the yield curve, the spreads, those are the factors. So any surprise in those factors, we don't take here a normal beta or a normal factor. We take the surprise in the factor. So we take the sensitivity, that is the beta, let's say for factor 1 into, when I say F1 is the surprise in the factor. It's not just the factor. So if I take beta 1, beta 2, these are what? Surprises in the factor. I will say these are surprise in the factor. Surprise is what? Unexpected change. So if there's an increase or decrease, that is surprise in factors, and the betas are also sensitivity of the surprise in the factor. So this is if there is a surprise. That is the big difference between fundamental and the macroeconomic factor models. You will see that difference. They are surprises. However, there is one more component in the model, which unfortunately I did not fit it here, that if all of these returns are, if there is a surprise and if there is no surprise, then there is something. These are all systematic factors. Am I correct? But then there is something which is unique here is the error. Yes, error. Here, error is very critical. What is the error here? The error is the factor not captured by the model. Which is that factor which is not captured by the model? It is the firm specific risk or company specific risk. Because here, all the factors that I've taken are systematic factors. So, company specific risk factor or company specific risk, which is also called unsystematic risk. That is the most critical component. So even though it sounds similar, if you will notice, APT is a simple model. Macroeconomic model is based on macroeconomic fundamentals. The error is when it is not systematic. It is the unsystematic risk is the error. Here, the intercept is expected return if there is no surprise. And these are all the surprising factors. How much is the change in the macroeconomic factors? Remember, surprise is nothing but the difference between actual and expected. Anytime you want to understand what is surprise, surprise is the difference between actual and expected. Simple. That is what we call surprise. Clear? Everyone? Correct? Now, fundamental factor model, I will rather do it on a new page because it has some interesting components. Fundamental factor model. These three models are the critical in this topic, and then there is a decomposition of allocation effect. Here also we will derive the return, but these returns are based on intercept, like what we did before. The intercept is not defined here. So it is simply the intercept of the portfolio is the minimum return plus here we are not using macroeconomic fundamentals. So what are we using? We are using company specific fundamentals like P ratio, size, style. So we will take two things here, the beta and the factor. The factor can be company specific like P ratio, even though it's a factor, but I will write. And second factor can be about the company's size, correct? Plus the error, error. Now, what is the error here? Error, as usual, is something that the model cannot explain. So error, in this case, I will first define error is the unexplained component. I cannot say now unsystematic errors because these are all company specific factors. So this is what we call unexplained. Okay. Remember the components. The unique thing in this model is the sensitivities and the factors. The sensitivities and the factors. The factors are associated with the company. So factors are fundamental factors associated with the company. They are not macroeconomics. They are fundamental factors. There can be more than two also. So they are simple fundamental factors, actual, not surprises like the macroeconomic fundamental. But the unique thing is about the sensitivity here. The sensitivity is called the standardized sensitivity. What is this called as? This is called standardized sensitivity. It's just not a sensitivity, standardized sensitivity like a z-score. Standardized sensitivity is like a z-score. So your beta is like a z-score. Means how do we calculate the beta here? Z-score is nothing but the actual minus the target over the standard deviation. So let's say if the factor here is P ratio, I will take the P ratio, which is the actual or the change in the P ratio. P ratio, how much was the P ratio before and later on. So we take the sensitivity of the P ratio. So let's say the P ratio 1 and P ratio 0, the sensitivity divided by the standard deviation of the P ratio. So we take the standard deviation of the P ratio. You do not have to calculate in exam. Don't worry, you do not have to calculate, but you need to know the meaning that these are standardized sensitivities. All right. So three models, APT model, macroeconomic factor model, and fundamental factor model. The components are important. The calculation is same. You will put up the components, you will get the answer. The difference is very, very important. What is the difference in the intercept year and the macroeconomic factor models? All right, perfect. Now, in the previous reading, what we did is that we calculated the active returns. And what is active return? Portfolio minus the benchmark. And we decompose them into asset allocation and security selection. Yes, we decompose them into asset allocation and security selection. In this reading, however, because it is based on factors, so what we do is that we decompose them based on factor. So we now say factor returns and the remaining are factor returns and the remaining are the same that we did before, security selection returns. So the remaining is same, but now we will break down the active return into factor and security selection return instead of asset allocation return. So what we do, we will take the change in the factors. So when I calculate my factor returns, very interesting, factor returns, what we do, how much is the beta of my portfolio compared to beta of benchmark. Remember there it was weights. We considered weights. So these are my factor returns, changes in the beta into the factor risk premium. Don't forget factor risk premium. Once you multiply this for all the factors, we do it for all the factors, that is our factor returns. So active returns we can calculate. From the active returns, we will calculate factor returns. Security selection is the balancing figure. So from the active returns, if I subtract the factor returns, that is my security selection. It is the plugin. Understood? It is the plugin. This is the decomposition of my active returns into factor and security selection. Unlike the topic where we differentiated between asset allocation and security selection. Understood? Same way we can decompose active risk also into factor risk, correct? So active risk is nothing but the tracking error, that is the standard deviation of active returns, portfolio minus benchmark. This can also be decomposed into factor and specific risk. Now see, risk is always systematic and unsystematic, right? So factor risk is systematic and specific risk is unsystematic. So we can break down this also into two components. We will say factor risk is systematic risk. So we will say active factor risk, and we say active specific risk, specific risk. But remember, risk is always calculated in square. So we will take square of everything. So this is also square. So we say active risk square. We say active risk square. So active factor risk square, active specific risk square. Understood? We always say in terms of square. Risk is always in terms of square. Remember, factor return plus security selection is your active return. Same way, if you do the square, then you can then you can add both, then it should match. So active factor risk square plus active specific risk square is your active risk square. Now, here, surprisingly, what we do is that we do not calculate the factor risk, we calculate the specific risk. And the specific risk is company specific risk that is due to the change in the weights. So the change in the change in the weights of the portfolio and benchmark, the change in the weights of portfolio and benchmark. So let's say what is my weight of security in the portfolio minus weight of security into the benchmark, that active weights everything square, okay, because we are trying to calculate in square, this square into my error. What is the error here? Error is nothing but the unsystematic risk of the security. So here we take the error variance. This is the unsystematic risk. This we will take for each security in our portfolio. This is your active specific risk square. So now from the active risk square, if I subtract the active specific risk square, I will get the balanced active factor risk square. Here, active factor risk is the plug, is the balancing amount. Active factor risk is what? Is the balancing amount. So when you do active risk square minus active specific risk square, that is your active factor risk square. Is this clear, everyone? All right. See, check here in your notes. Where is this? Yes. Active factor returns, security selection returns. We did the calculation also, right? Unsystematic risk, and the remaining is factor risk. Correct? We did the calculation related to that as well. Then finally, there is Carhart and Pharma-French model. Pharma-French is three-factor model. Carhart is four-factor model. So if you just do the Carhart model, you can actually understand Pharma-French also, because the first three factors are same. So let us write the Carhart model for your reference. So we will do the Carhart model. It's a multi-factor model describing the expected return. So expected return now, very simple. Expected return on the portfolio is risk-free, plus we take Pharma French takes the three factors. So we will take the factor one, that is the market risk premium, right? That is the market factor. So we here take RM minus RF. The first factor is RM minus RF, the general factor that we take, uh, market factor, right? RM minus RF. This is the market risk premium. This is common in CAPM also. But the second factor is for the size. That is the small minus big. So this factor is second factor that is related to the size. We call it as SMB. You do not have to memorize. It is small and minus big. Third factor, I will write down the third factor. The third factor is related to valuation. So it is high market to book value ratio. So high minus low book to market value ratio. So we say B3, high to low. So high to low is HML, high market value. We take book to market value, high minus low. Okay, you do not have to memorize it. These three factors are common. They are used for Pharma French. So when I take only these three factors and risk-free, this component becomes what? Pharma French model. I will write down. This becomes Pharma French model. But if I want to find Carhart model, I will add back a fourth factor. That fourth factor is momentum. That fourth factor is momentum factors, and the momentum factor is winners minus losers. So we say winner minus loser. That is the momentum factor. So when I put up this fourth factor, then it becomes Carhart model. That's all you need to know from this topic. So this is your reading number 4. Everyone, very, very important. All these factors, APT, then macroeconomic factor model, fundamental factor model, Carhart and Pharma French model, and the decomposition of active risk and active returns. Now, moving to reading number 5. Reading number 5 has an amazing calculation of VAR. Everyone knows what is value at risk or VAR calculation. Very, very high chance of that being tested. One of the common ways of measuring VAR is parametric method. So what is the parametric method of measuring VAR? Parametric method of VAR calculation is nothing but the same formula that we did in level 1 for calculating portfolio variance. So that is nothing but portfolio variance. So what is portfolio variance, everyone? Portfolio variance is weight of A square, variance of A, assuming two securities, weight of B square variance of B plus 2 WA WB covariance AB. Covariance can also be split into correlation. That will give you the portfolio variance. This portfolio variance, everyone, this is going to become very important because when we calculate the standard deviation and mean of portfolio, we can calculate VAR. So in order to calculate the VAR, how do we calculate VAR? Remember, VAR gives you three things. What are the three things? The minimum loss. I will write down that also. That is important. The minimum loss, the probability of that loss, and the time. Right? That is the three things that VAR provides us. So we always write VAR as, let's say, daily 5% VAR is $20,000. So I say that there is a 5% chance that my minimum loss will be $20,000, or there's a 95% chance that my loss will not exceed $20,000. So how to calculate this 5% VAR? To calculate this 5% VAR, I require the mean, the standard deviation or standard error, into the z factor, which for 5% is 1.65. This 1.65 is the standard value for 5%. Remember that standard value for 5%. This VAR is always a loss. Remember, VAR is always a loss. And multiply that with the amount that they will provide you, multiply that with the notional principal. So that will give you the total, or you can say the total portfolio value. So notional value or notional principal. So let's say you are calculating VAR on a $1 million portfolio. So you'll multiply this with 1 million. VAR is the minimum loss. Highly testable. In level 1, you did not calculate VAR. You just knew what is the meaning of VAR. Here you will calculate VAR. Remember, once I get VAR, let's say if I get a daily VAR, how do I convert it into an annual VAR? Everyone, from daily VAR, how do I convert it into an annual VAR? You will multiply the daily VAR with the number of trading days. Number of trading days and the root of it. We take the root. Why? Because it's all in standard deviation. If you're doing it all in standard deviation, you will multiply that with the trading days. So if you want to calculate daily VAR, you will take the daily standard deviation. Yes. But if you want to find the annualized VAR, you will annualize the VAR in this manner. You will calculate the daily VAR and then annualize it. So if you have the daily returns and daily standard deviation, you can calculate the daily VAR. If you want to calculate if you have the annualized return and annualized standard deviation, you can calculate the annualized VAR. But if you want to convert the daily VAR to annualize, multiply with the root of t. Is this clear, everyone? Multiplying with the root of t. So in this topic, honestly, the calculation of VAR and conversion of daily VAR to annualized VAR or monthly VAR to annualized VAR. So look at the trading days. They will provide you with the trading days. Generally, it is 250 days in a year. So I'll have to multiply with 250. All right. That's it. Reading number 6, backtesting has no formulas. It is all about sensitivity scenario analysis. So there is no formula in reading number 6. This is where portfolio becomes critical for many because there are massive amount of formulas in portfolio. Very highly weighted, too many formulas. All right. Yes. Anyone, any questions? Yes. Okay, so what is adjusted breadth? Now, suppose this formula basically tests that, let's say I took 5 bets. So should I take my breadth as 5? No. Out of this 5, what if couple of bets are highly correlated? Let's say all of these are highly correlated. So if the correlation is 1, assume the correlation is 1 amongst all bets. So if the correlation is 1, what will this ratio transform into? 1 into n minus 1. Let's say I took 5 bets, right?
Yeah.
So if you put 5 here, 5 divide by 1 plus 5 minus 1 is what? 4. And the correlation is 1. So this will be 1 only,
One.
isn't it?
Yeah.
So this will correct the problem that bets which are similar cannot be considered different breadth.
Okay.
So it fixes that issue. That is the adjusted breadth. So we always used to take adjusted breadth. Otherwise, it will by mistake calculate a higher information ratio. So the maximum correlation is 1. If the correlation is less than 1, let's say the correlation is 0. If it was 0, if the correlation was 0, if the correlation was 0, then the entire component will be 0. Then I will consider it as 5 different bets.
Got it.
So I don't want the correlation to be high amongst the bet. Then only I will consider them unique, otherwise not.
Got it. And lastly, also the
Yes.
2% correct minus one, the IC.
Yes. This again, see, this is about, first of all, IC measures what? IC measures actually nothing but the intelligence of the analyst. So it is the correlation between forecasted and actual. Okay. Now, an analyst can be right 50% of the times, means 50% of the times he's right in the sense his forecasted are close to the actual, but the other 50% it is not. So if you're 50% right, so if your 50% of the decisions are correct, so if you will do 2 into 50%, 2 into 50% is 1 minus 1, so actually I see 0.
Yeah.
We will not consider that as his forecasting ability is good. So this actually makes it better that it will reward you only if your forecasting is more than
Higher.
50% time accurate.
Okay.
It should not be only higher, because see, half of the time you are accurate, half of the time you are not. So in reality, I gain nothing. So I
Yeah.
want it to be higher than 50% of the
50%. Yeah.
times correct. So this adjustment in the IC and in the breadth fixes the technical issue with them.
Okay.
So it
Yeah.
filters
Understood.
out those which are just by luck.
Okay. Got it. Yeah.
Yeah.
Cool. Thank you.
Thank you.
We'll
Yes.
see you tomorrow.
Yeah.
Thanks. Bye.
Bye. All right. So yeah. Hi. So we are starting with financial statement analysis. Now, financial statement analysis is around 10 to 15%, a massive topic with 6 readings. All of these readings are giant. Now, well, FSA formally doesn't have any formula, but there are a couple of things that you need to remember in terms of calculation. So the intention of this is to highlight those factors. But yes, there are some cases where we do have formulas, especially when we'll go to the ratio calculation of banks, insurance. There are so many formulas. So I will focus on the ratios there. Okay. So let us start with first reading intercorporate investment. Now, in this reading, what are the areas where we need to highlight on? Remember, this reading has the 3 important methods of recording our forex transactions and exposures. So 3 major exposures are transaction, translation, and economic exposure. So we will focus on that. But before that, how the investment in foreign activity, or what is the classification of investment in foreign companies, which is based on the control. Okay, so there are, first thing we will focus on, what is investment in associates, or what is the first thing, investment in financial assets. Then there is investment in associates, right? And we have a reference as to holding. So when I say, when my investment holding is less than 20%, we say investment in financial assets. When that is between 20 to 50 percentage, although it is not the only criteria, but this is a very important criteria, then we say investment in associates. Then comes business combination. business combination, this is when the investment is sizable, it is greater than 50 percentage. In that case, it is greater than 50 percentage. This is invest business combination. And then there is a discussion about joint venture as well. Okay. Now, these four categories is what we discussed throughout the syllabus. Investment in financial assets has three methods, that is held to maturity, available for sale, available for trading, which as per IFRS is amortized cost, FVPL, FVOCI. So there are no calculations there. There are treatments as to what is recorded where. There is a calculation with respect to investment in associates. And for that, when we focus on investment in associates, which method do we use? For investment in associates, we use equity method of accounting. So when I say investment in associates, under this case, we do equity method. We apply equity method for accounting. And under equity method, I hope the revision notes are there with you, so you can actually check simultaneously in the notes also in depth what is the terminology or what are the components, right? This is where you can check. Now, when it comes to investment in associates, under this, there are three major things: how it is recorded in the income statement, in the cash flow, what is the impact, and what is the impact on the balance sheet. For this, in the notes, you will see we had written it down. We will discuss the same thing here. And all of that is discussed in the section related to goodwill adjustment. So you will see the calculation of goodwill, then you will see what happens in the income statement, what happens in the balance sheet. These are very critical, and this is what we will first address. So first I will address how it is recorded in the income statement. First of all, there are two participants here. One is investor and investee. Yes, before we go ahead, let us discuss who is investor and investee. Investor is the one, investor is the one investor is the one who's going to invest, correct? Very easy. Investee is the target company here. I call this, in simple language, it is not always the case, but I call it acquirer and target. This will help you easily understand. So we are doing all the accounting for the investor. Investor is what, where we are doing all the accounting. So what goes into income statement? What is the impact on cash flow statement? And what is the impact on balance sheet? Now you would be wondering, where is the formula here? Yes, there is a discussion related to formula. In the income statement, we will record the investee company's share of profit. So basically, we record how much is our investment into the investee company's profit. All right. So number one thing, we record what? The investee company's profits proportionate share. So here we record our investors' share in the investee companies. So let's say investors percentage into profit of which company? Profit of investee company. I call it as target company. Okay, for our easy reference here. So whatever is investee company's profit, of that, how much is our share is what we will record. And if there is any adjustment related to extra amount for depreciation, now that is something which is very critical. So we will record the profit, but in the income statement there is one more thing that you will notice, and this happens when you're going to acquire that company. There is a goodwill recorded. So any additional adjustment for depreciation, yes, because you may have purchased the company. Of course, when there is a goodwill, you purchase the company above its fair value. So that extra amount or that extra amounts, amortized or depreciated over the period, we call that as extra depreciation. In the class, we wrote that as an extra depreciation. Officially, it is called adjustment due to excess excess depreciation. Again, for simplicity, you can call it as extra depreciation. And this extra depreciation is because of what? It is because that you purchase the company over and about its fair value. So that's the reason why all of this is discussed in case of goodwill also. So goodwill will also be discussed in terms of calculation. We'll do goodwill also. Okay. So this is what will go into the income statement. If there is no extra depreciation because of adjustment, just simply investee company's profit into investors' proportionate share. In the cash flow, only one item is recorded. What is the item that is recorded? Is the dividend paid by the investee company. Yes. Any dividend that is paid by the investee company, is that a cash inflow for the investor or cash outflow? Well, that is a cash inflow. So we will take again investors percentage into dividend of the investee company or the target company. All right. Now, finally comes the investment account on the balance sheet. So this will have three items. One is the beginning investment amount, the amount that you have invested, and anything from the income statement amount, income statement profit, or simply the income. You can say simply the income here. So instead of saying income statement profit, I'll just write income, and then there is dividend. Now, which one is added? Yes, the income is added, but the dividend will be subtracted. Do you understand why the dividend will be subtracted? It's like return of capital. So from the investment account, the dividend is subtracted. Is this clear to the class? Right? In the same page, I will write the goodwill formula also. What is the goodwill formula here? Goodwill is the excess price that you have paid to acquire that company. So goodwill, calculation of goodwill, I will write down here. Goodwill is related to two things, right? What is the calculation of goodwill? First thing, we will take the purchase price, the amount that you paid, purchase price to acquire that company or to take a stake in that company, minus we will subtract the fair value of net assets. But will I subtract the entire fair value of the net assets? Everyone in the class? No, we will subtract the fair value into our investment percentage. So we will subtract the fair value of net assets of investee company multiplied with what? Multiplied with what? The investor's share. I hope you're getting it. Multiply with the share of investor. Have you understood this? What I've written? Everyone? Because see, there is no formula as such. But hope you understand what we've written. So let's say I paid $100 million to acquire the company whose fair value of net asset was some amount. But I didn't buy the entire company. So whatever proportionate share I bought, that fair value is compared with the purchase price. Is this clear, everyone? So I'll repeat, what is goodwill here? Again, it's in the notes, but still here, you can check it here. But still for your reference, purchase price minus fair value of net assets of investee into our proportionate share. R means investors proportionate share. Is everyone clear with this? This is the adjustment of goodwill, balance sheet, income statement, what goes into the cash flow with respect to equity account. Anyone has any doubt here? All right. Okay. Now, the other mode of investment is in business combinations. In associates, we discussed in case of business combination, which method do we use? Business combination. Under business combination, we use the consolidation method, which is also called as acquisition method. Everyone, correct? Visible? Hello? All right. Yes. Now, In business combination where the investment is more than 50 percentage, there are two goodwill approach under the acquisition method. One is called a full goodwill, and then there is something called as partial goodwill approach. Okay, first of all, goodwill is only recognized by the parent company. We will say the parent company, the acquirer here. So there are two goodwill methods. So for goodwill, I will write the full goodwill method, and then there is a partial goodwill method. In the class, I discussed you how to solve this without formula also, with the explanation where we discuss that we find the full value of the company and then we do the partial value of the company. I will just show you in the class we discuss this, how to find the full value and the partial value. So in the class we try to do it without the formula, but still we have all the formulas here. So we will write what is the full value approach and what is the partial value approach. So when I say full value means the purchase price is not for the entire company, it is for some percentage. So we'll try to find the full value of the company. So in this case, my goodwill calculation, and in this case, my goodwill calculation. So what we did, we paid the purchase price. So purchase price divided by the proportionate investment share. So whenever I write percentage, I'm writing basically the percentage owned by the parent. This will give me the full value of the company, right? From this, I will subtract the fair value of net assets of the investee. Yes, so this is the full goodwill value, fair value of net assets of the investee. Remember, or we always take the tangible assets. We ignore the goodwill of the target company or the subsidiary. All right. This is called the full goodwill approach. Partial goodwill approach is pretty much simple, where we only take the purchase price. We only take the purchase price. And from that, we simply subtract the proportionate fair value, right? So we will take what fair value of net assets into the proportion owned, into the proportion owned. Now, this may sound similar, but the valuation might be different, right? So because of this, the goodwill amount might be slightly different. The full goodwill approach is acceptable under IFRS and US GAAP. The partial goodwill is only IFRS. So I will write this for your reference. This is acceptable under IFRS and US GAAP, but the partial goodwill is only allowed under IFRS. So partial goodwill, as we know, IFRS is the one who gives choice. So partial goodwill is only allowed under IFRS. If you notice carefully, the partial goodwill approach is the same approach that we use in equity method. In equity method also, we did the same thing. Purchase value minus fair value of net assets of investee into the proportion of investor. It's the same approach, partial goodwill, right? But there is another approach. When you do business combination, you are the owner of the company. So basically, you are the parent company. So you take the full goodwill approach also. Similar to this, there is a full goodwill calculation for non-controlling interest. Yes, so this is what we did, the goodwill calculation. Now, if I extend it further for non-controlling interest, what is non-controlling interest? Non-controlling interest, it is that proportion which is not owned by the parent, correct? So that is this, what we did was for goodwill. Now in the same category, if I want to calculate non-controlling interest under the full goodwill and the partial goodwill approach, be careful here. Again, full goodwill means you'll try to find the entire value of the company. So the purchase price that you paid is for the proportion. So you always try to find the full value of the company. So same thing we will do. We will take the same component, purchase price divided by the percentage of the company that we own. We will take that. Now, into what we will do, this is the full value of the company into very logical, non-controlling means the percentage not owned. So what we do simply is we multiply this into percentage not owned. Percentage not owned, as simple as that. Understood, everyone? In the non-controlling interest, we do the same thing. Yes, we also do the same thing. We say percentage not owned. Fine. That is percentage not owned is there. But then we go and multiply not with the price that you paid, but with the fair value of net assets. So here I take what? Fair value of net assets of the company. So we take the fair value of the net assets of the company. Fair value of net assets of which the company that we are acquiring, that is the target company. All right. Of target company, or we can say here the subsidiary. All right. This both amount will be different. Very important. Okay. Now, in the class, I discussed that it is least likely to be tested, but you should be aware. So, what is the full approach for goodwill calculation and partial approach for goodwill and for non-controlling interest? This is one stuff that students sometimes get worried how this is calculated. So, this is where you may require the formula. All right. This is again, which approach? We are doing this acquisition approach. So two approach in equity method approach and acquisition approach. These are the only areas where you have formula from this topic. So you have, they will probably ask you something related to this where you require formula. How is the treatment? Investment account calculation they might ask, or they might ask the goodwill treatment. Yes, everyone clear with this too? Okay. If you check in the notes, formula is only, this is the area where you may require formula. Now, the second reading, which is very interesting because there are two components here, share-based compensation, which has a lot of formula. And then, of course, the favorite is pension. So with respect to pension also, we will see several formulas. Now, in this case, the two major calculation issues that students face with respect to share-based compensation is the fair value calculation and compensation expense, which is a bit tricky. And then we calculate something called tax windfall and tax shortfall, if you are aware. Okay. So we are now moving to reading number 2, where we will first focus on the share-based compensation. So first I will focus on share-based compensation. Remember, share-based compensation, the most important is grants, stock grants, and ESOPs, employee stock option plans. So here we had fair value calculation. Now remember, fair value is calculated at 2 points. Fair value calculation, fair value calculation at the beginning, that beginning date when the compensation is allotted to you, what is that called as? Fair value at 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 grant date, grant date. And then there is a settlement date. Are you aware about this? The fair value calculation in exam, you might be required to calculate on grant date or settlement date. This is how we will calculate for stock grants and employee stock option plans. Okay. So how do we calculate for stock grants? Stock grants. Then we calculate for employee stock option plans. And similar to stock grant is RSUs. If you are aware, RSU is restricted stock units. So restricted stock unit. What is the only difference? We will discuss. So first of all, on the grant date, wait a minute. I will also consider RSUs here, which is related to stock grant. RSUs restricted stock units. All right. Yes. So bear with me. Yes. So first of all, we take what the grand date values. Whenever I say grand date or this grand date, I will write the shortcut. Grand date is GD. So fair value of the compensation. So basically we take the grand date market price of the company and the number of shares that are granted. Okay, so we take the grant date market price. Whenever I write market price, everywhere you will notice when I write market price, it's always grant date. Grant date. On that day, what was the market price of the company into the number of shares. So into the number of shares that are granted. So I will write into number of shares granted, number of shares given or granted to you. We cannot say technically given, the number of shares granted, okay, that you are eligible to receive. RSU also the formula is same, just that in RSU you will not receive the dividend. So what we do, the formula for RSU is same. We also do the same process, just that on that day, if the company declares any dividend on the grant day, we estimate the dividend and we assume that because it's an RSU restricted unit, you will not receive that dividend. So we only on the grant date, we need to subtract the present value of dividend. We need to subtract the present value of dividend. This adjustment we have to do only on the which date? Only on the grant date. This estimation. So what we write? Market price of the shares on the grant date minus the present value of dividend until grant. That is estimated into number of shares. This minor adjustment is needed in RSU because in RSU you will not receive the dividend. Is this clear? If you notice, if there is no dividend, the fair value on grant date for RSU and stock unit is same. Is everyone clear with this? ESOPs are options. So we don't say grant date market price of share. We say grant date fair value of option using binomial or Brackens code. So we say fair value of options. We say fair value of options on the grant date, into, I will not say number of shares, I will say number of options granted. So we will say number of options granted. Okay. So market price per share into number of shares granted, market price per share, everything on the grant date. Grant date is the date initially. And when the shares are actually received, that date is called the settlement date. All right, everyone? Clear? In your notes, I have mentioned this, where is it? Very properly, we have, yes. This is where you can see we have discussed this in detail. What is the stock compensation amount, or what is the fair value on the grant date? What happens on the RSU case? What happens in the case of employee stock options? How do we record them? Right? That all is discussed here. And in the class also, we wrote down all of this thing, right? This is how we measure the fair value. But because it's scattered around, because we do it in stages, when we revise everything, we need everything at one place. So on the settlement date, what is the fair value? Now, again, I will take market price of share. MPS is market price of share, but on the settlement date. So here we take what? We take market price of the share, market price of the share on the settlement date. But in case of employee stock options or stock options, simply, in that case, we take what? We take whether the option is exercised. If it is exercised, I will have to pay. So the gain is only the extra amount. So then in that case, we take the settlement date price minus the strike price. So we take the settlement date price minus the strike price. That X is nothing but the strike price of the option. This is different here because in option, the extra amount is the gain. All of this into number of shares. Okay, simply the number of shares that you will receive. That is your fair value on the settlement date. Everyone, is this clear? I know it's complicated, but yes. So if you see that, if you notice, the difference is due to two things, right? The share price on the two things means on the settlement date and the grant date. So the settlement date price and the grant date price, settlement date price and the grant date price. Now, either it will be greater or lesser. Of course, it will not be same, right? So if it is greater and if it is lesser, what is that called as? If on the settlement date, if the actual price is much higher, this is where there is a difference of financial and tax reporting. So if the settlement date price is actually higher, that means you will have in the past whatever in the financial statement you recorded. Now in the tax reporting, you will be paying what? If the settlement date price is higher, in that case the tax amount paid will be higher. So if the settlement date price is higher, what is the conclusion? If the settlement date price is higher, well, that will result in tax windfall or tax shortfall. So if the settlement date price is higher than the grant date, that means the tax deduction that you're going to get is going to be more than the reporting. So in that case, we call it as a tax benefit, right? It's a tax benefit because I will get more tax deduction. That is called tax windfall. But if the settlement date price is lower, that means the tax deduction will be lesser than the financial reporting or the accounting reporting. That is called tax shortfall. Remember, tax windfall and tax shortfall is the comparison between the settlement date price and the grant date price of the stock. Is this clear, everyone in the class? Check and confirm. All right. One formula that you are required to understand is the compensation expense. Compensation expense under the stock based performance. This is what the company will record in the income statement, because what we will do is we will systematically allocate the compensation over its life, and here the life is vesting period. So the fair value that we have calculated, divided by the vesting period will be provided to you a couple of years or so. That is your compensation expense, fair value divide by the vesting period. Very, very important. All right. This is what we will report in the income statement. But one more adjustment we have to do is that because these shares will be added, there will be new addition of shares. And because of that, what will happen? Your EPS will get diluted. So what we did apart from this is we calculated the diluted EPS using a method which we call as treasury stock method. Under this method, we actually did this in level 1 also. We had to calculate the net shares added. So now I will write a formula related to that. Net shares added. This happens in the case of stock options also, and in the case of grant also. Now, the irony here is that in the case of stock option, you do receive money, right? When the employees exercise the option. But in case of stock grants, do we receive any compensation? Do we receive any form of a compensation in case of stock grants? Well, in case of stock grants, we do not receive any compensation. So there is no compensation received in case of exercising the stock grants. It's free. However, there will be some adjustment also. So instead of just taking compensation expense, what we do is that we take the entire amount, which is called total cash proceeds. So cash proceeds is something unique here. So cash proceeds is what we account for. And apart from cash proceeds, one more thing we adjust, because cash proceeds will not always be the case, right? It will only be the case if it is an option. So along with cash proceeds, we take average unrecognized compensation expense. Compensation expense is like a depreciation. So depreciation, whatever is recorded till now, is called accumulated. The unaccumulated or the depreciation which is not recorded, that is similar to that, we have something called average unrecognized compensation expense. So we then add average unrecognized compensation expense. And I have told students to remember a shortcut for this. Does anyone recollect what is a shortcut for this? This is simply nothing but your compensation expense, because this is average, right? So if it is straight line, guys, if it is straight line, will the compensation expense change? No. If it is straight line like depreciation, will it change? No. So it is simply compensation expense only. Understood? So cash proceeds, remember cash proceeds in case of option, there will be cash proceed, but in case of grants, there will be zero. Plus average unrecognized compensation expense, that is called total assumed proceeds. Total assumed proceeds. This is the total inflow that the company is expected to receive. With this proceeds, what we do is that we will go and purchase the shares in the market. So we will, this total assumed proceeds that we get, divide this by the average market price of the stock. Don't take the closing price, take the average market price of the share, and that is going to be your shares that you will repurchase. That is called the shares repurchase. So that is what is going to be the shares that I will have repurchased. Now remember, these shares which are repurchased will be subtracted, and the shares that you issued or you have to give to the option holders. So the shares that you have given to them or granted, shares issued because of shares granted or shares due to stock option, the net difference between both is called net shares issued, or that is what we call as net shares issued. So this will be added to the original shares. So let's say you had some beginning shares outstanding plus the net shares issued. This will be your total shares which you will use for dilution. So this will be my total dilutive shares. This is going to be my total dilutive shares. All right, so let's assume you had initially 1 million shares, and now the net share issued are 100,000. So you'll have 1.1 million share, which will go in the denominator of your EPS calculation. That will be your diluted EPS. Got it, everyone? All right. You can recollect this when you revise FSA. So, right now you may not recollect if you're just watching the formula session. You will recollect that when you are done with the, particular topic. Let's say you are done with FSA reading, then perhaps you should go towards these formulas. Then you will recollect it immediately, whatever I'm writing it. If you're directly seeing the formula, you might be wondering what's going on, right? So utilize this formula session later on when you revise the topic. Let's say you are revised with FSA, quickly then check the formulas. Okay. This is where we have placed up all the formulas related to stock options. The second part of the topic was about pensions. So in case of pensions, this is where many students have a problem. Okay. In case of pension, our focus is on the DB plan, and on the DB plan we have a funded status, which everyone knows. Funded status is not a problem. Funded status is the difference between two things, the assets and liabilities of the plan. What is the asset called as? Fair value of plan assets. This is basically your investments, therefore it is at fair value, minus your obligation. That obligation is estimated, so we call projected benefit obligation. We call it as projected benefit obligation. Now simply said, you can say plan assets and PBO. So I call plan assets and PBO. The difference between both is called your funded status. If the plan assets are more, it is overfunded. If the PBO is more, it is called underfunded. No need to have any formula for that. Now, for your exam, students are expected to know what will go into the income statement and what goes into the balance sheet. Now, there's a high chance that the balance sheet amount will be provided to you. So when we did the plan asset discussion here, how it is recorded on the balance sheet, what is the component of fair value of plan asset, what is the component of PBO, that is what we recorded. You may not probably require this in exam, they may provide you, but still I will write down so that you understand what goes into the fair value of plan asset and what goes into the projected benefit obligation. Now these names you should know, and you should know what are the components of it. Remember, these are not recorded separately on the balance sheet. On the balance sheet, only the net effect is recorded. Even though I'm writing here, we are not going to record both on the balance sheet. We only record the net item. So under the fair value of plan asset, it is like an investment account. So you will have something at the beginning always. So you will have beginning plan asset balance. Okay. In that, any contribution by the employer will have to contribute. Employer contribution, I will write the short form. Employer contribution will increase the plan assets, and the returns, yes, the plan, that is the investment, will generate some returns. So actual returns on the asset, these actual returns on the plan asset, that will also be added. However, if there is any benefit paid to the employees, that will be deducted from the plan assets. So we say any benefit paid to the employees, specifically to the retirees, that will be subtracted. And finally, what you get is what we call as the ending balance of plan assets. Ending plan assets. This, again, there's a high chance you may not have to do this. They probably will provide you, but you should know what are the components. The investment value will increase with more contribution, more returns, and reduce when there's an outflow. Consider the balance, the benefit paid like a dividend paid from the investment account. Got it? PBO also has the beginning balance. So there will be a beginning PBO. It's a liability, right? So the liability will increase with what? More and more people working, or simply as the year passes. Now, this is where we will discuss what is service cost. Service cost, right? This is the benefit that the employer earns for the current year. Will this increase my liability? Yes. Then similar to service cost, there is something called past service cost. Past service cost and past service cost. All of these details I've mentioned in the notes, so you can go back there and refer it. But this is just, we are writing the formula. Past service cost, as the name suggests, it's the benefit of the past that you're going to be eligible today. So this past service cost may or may not happen. Okay, these are retroactive benefits, and because they disrupt the plan, so that is where IFRS and US GAAP have difference of treatment. Some says in OCI, one says in income statement. So there may be something called past service cost. Again, if there's a past service cost, it will be added. It will increase your liability. All right. Then there is a time value of money cost, which we call as interest cost. So your liability is like a zero coupon bond or any bond. Remember, a discount bond's liability keeps on rising due to the pull to par effect, like amortization. So that's a natural increase. All right. Then there is something called actuarial gain or loss. This actuarial gain and loss is because of any changes in the assumption. Well, this can be plus or minus. It can be either of the thing, right? Because the assumption may be sometimes increase the liability or sometimes it will decrease the liability. For example, interest rate reducing will increase the liability, interest rate increasing will decrease the liability. So there can be actuarial gain and loss. And of course, there is the benefits paid. If there is any benefits which are paid, remember, benefits will paid. Benefits paid is like liability paid. So benefits paid to retirees, will that increase the liability or reduce the liability? That will reduce the liability also. So benefits reduces the asset because it's an outflow paid to them. It reduces the liability because it is paid. That will be your ending value of PBO. Ending value of PBO. Guys, let me tell you very honestly, I am also not that smart. I remember it because I write it. When I gave the exam, I struggled with this, so I wrote it for my reference. When I wrote it, I was not confident will I remember or not. Will I remember or not? Because there's an anxiety and impatience. How should I remember all that thing? You may not, but it's okay. At least write it. It will give you some clarity. Maybe later on, maybe you revise it 2 or 3 times, then it will freeze in your head. There's a high chance it may not be required at all. But writing is the best option. Just looking at the information will not help. Okay. In pension, students have a problem with, sir, what is the component, right? That is one thing. The second issue that they have is that where what is recorded. Now, where what is recorded, of course, I cannot discuss that in the formula. We've covered that in the revision, how to remember, what not to remember. Here, I will focus on the other component, which is very important, is how the pension expense is recorded. Remember, pension expense is recorded in the income statement, or some components are recorded in OCI. So it's an expense. What are the components of pension expense, everyone? That we will discuss. That is very critical. Now, here, the difference is due to IFRS and US GAAP. They both have a clash here. So, what is the pension expense and how it is recorded, where it is recorded? Of that, the only difference in terms of calculation and formula wise, you should remember that how it is treated under IFRS and how it is treated under US GAAP. US GAAP is slightly complicated because there is something called corridor approach, which I will tell you what to do about it. So in US GAAP and IFRS, pension expense, it's an expense. Let's say it's a expense that the company will record every year in the income statement. So in this case of IFRS, there are total how many components? There are total three components which you should be focusing on. Number one is your current year's cost. So current year's cost, that is current service cost. Current service cost, that is common under both. This current service cost is nothing but what is the benefit that the employees are eligible for the current year of salary. That is our current service cost. This is common under both. The problem happens in the next. The next one, which is called net interest cost. In IFRS, we call net interest cost, and this is where there is a difference. US GAAP says only interest cost, it doesn't net off. So in US GAAP, we say interest cost only. Now, what goes into the interest cost? Let us write down. By the way, again, I will repeat, it is mentioned in your notes here where we had discussed in length, and that's why you see my notes being messed up, and I'm sure it's yours as well. Now, understand there is a liability also, and there is an asset also. Asset will generate some returns, which is what we call return on the asset, and the liabilities will keep on increasing because of the discounting rate. US GAAP here differentiates both. US GAAP says that the liability is calculated at a different rate and return on assets are estimated at different rate. So we will first write down for US GAAP. Under US GAAP, in the interest cost, there are two components. I will write there, and both are different. It says that on the liability that is my PBO value at the beginning, that is my liability at the beginning of the year, into the discounting rate. The discounting rate is like, as I said, a discount bond keeps on increasing. So we multiply with the YTM. That is how we find the pull to par effect. So this is what will be increasing your liability. But This is what will be plus. This will be increasing my expense, correct? But there is asset also. So any expected return on assets. So let's say there is plan asset amount at the beginning, plan asset amount at the beginning, into we multiply with the expected returns. Expected, we estimate the returns. Now, as per US GAAP, these both are different. IFRS says no. Why do you need to calculate plan asset and plan liability separately? We will assume both as same. So IFRS says that simply take the difference between the plan asset and plan liability. So what IFRS says that don't calculate this separately, right? One is on PBO, one is on plan assets. Rather take what? PBO minus plan asset beginning values. Simply taken PBO and plan asset beginning value. See what IFRS does. IFRS assumes that why to have a separate rate on them? Let's simplify it. Assume both has the same rate. So IFRS says simply on this calculate the discounting rate. Simply on this calculate the discounting rate. Now you will notice that if the estimated rate of expected return and liability under US GAAP is same, only then these two are same. But that is not the case. So there is a difference. Have you understood this? Everyone in the class? Got it? This is the major difference between both, how they record it. Correct? Now, US GAAP has further costs apart from that. If you will notice, there in the pension expense there is something called actual gain and loss, which is there in pension expense, but that doesn't go into the income statement. That goes into OCI. And in US GAAP, there is also amortized cost, amortization of actual gain and loss. They may go into first into income statement and then into OCI. So the remaining cost that you see here, even though it is there, it will not go into OCI. And in US GAAP, first this amortized cost, the past service cost first goes into OCI, and then the amortized portion only comes up in the income statement. So therefore, I will write amortized past service cost only in the in the income statement. So this, if I focus this on the income statement calculation only, what goes into IFRS income statement, US GAAP income statement. So here we will add only the amortized past service cost. So we will add the amortized past service cost. Amortized past. Now I do write all of this, but unfortunately there's a high chance that they may not ask you in-depth such calculation. So that is the unfortunate reality. Okay. Now similar to the past service cost, which is amortized, it is first recorded in OCI under IFRS and that put up into the in US GAAP, and then the amortized portion is put up into the income statement only. In case of the past service cost for IFRS is recognized in the income statement only. So past service cost total. So here the past service cost will be added, but the entire amount, there's no amortization. So past service cost fully recognized in the income statement. So we write full amount. Here you will notice it's the amortization. It's the amortized amount only, but here we record the full amount of past service cost. This is where there is a issue with respect to IFRS and US GAAP. But if you are doing the income statement in IFRS, you will just see one time the past service cost fully. In US GAAP, you will see the amortized effect. So in US GAAP, the pension expense will be actually lower, right? What about the actual gain and loss? IFRS says actual gain and loss is never recorded in the income statement because it is changes in assumption. US GAAP first records in OCI and then amortizes in the income statement. So yes, in US GAAP, we add, along with past service cost, we add the amortized changes in gain loss, right? So we add the amortized actuarial gain and loss, but we use an approach called corridor approach. Now, this corridor approach formula I've mentioned in the notes. My suggestion is don't go into that calculation mode. It is very difficult. Just remember where this is recorded. This is recorded in the income statement. This is the worst thing that probably they can ask. I don't expect them to do so. But if they ask, this is the summary. So when you are revising pension, now see, you can take it positively also, that only 2 pages. You can take it negatively also. Oh, it is too much. But this is what it is. So what is the balance sheet? I've just discussed what goes into the balance sheet, what goes into the income statement, what goes into OCI. You can actually refer it from the notes, because US GAAP, in IFRS, only one item. In fact, I will write here what goes into OCI. It's written in my notes here. In case of IFRS, everyone, if you will notice, the OCI component is focused on actual gain and loss. In case of US GAAP, it is past service cost initially recorded, then there is actual gain and loss, initially OCI, and then amortized. So that's the only difference about OCI. I don't want you to focus too much on OCI treatment. Just understand the expense in a pension expense components. Then there is a last thing here. What about the cash flow statement, which is the easiest of all? So in case of pension, what goes into the cash flow? So this is the simplest. All of this calculation that you did was actually hypothetical. In the cash flow, there is only the contribution from the employer. So whether IFRS, US GAAP, doesn't matter. Only employers contribution is the cash outflow during the plan. Okay, that's it. Employer's contribution, because the pension will be paid from the investment account, right? So this is treated as a outflow from CFO. It's a CFO outflow. So this is how you remember what goes into the balance sheet, what goes into the income statement, what goes into uh, cash flow statement. All right. These are the only formulas that you need to remember. Understood, everyone? Clear? Right? All good till this point? Yes. Now, in multinational operation, the topic is very vast. Uh, you have to go through the methods, how they are evaluated, how they are calculated. For example, there's no such formula as such that you need to memorize or remember, but you need to know one important thing, that when which method you use. When you use the current rate method, when you use the temporal method, what about the presentation currency? What about the functional currency and the local currency? Under which case we use which methods? So there's no formula, but I will just connect here that when the FC and LC are same, and the FC and PC's presentation currency are different, then we translate. We translate using current rate method as visible on the screen. So you can write it for your reference. This is one thing. Temporal method, when is the temporal method used? When FC and LC are different. And when FC, LC, and PC, all three are different, we use both the methods. We first do the remeasurement using temporal method, and then we translate using the current rate method. So this is critical. It may not be a formula, but this is also noted in the notes exactly. I will tell you here. So which method is to be used and when? Which method is used to be when? Everyone, local currency, functional currency are same, but functional presentation currency are not same. That is where we use the current rate method. The reason of using current rate method is also we assume that the Subsidiary is independent of the parent. It takes its own decision. But functional and presentation currency are same, but local and functional currency are not same. That is, we assume the subsidiary is fully integrated with the parent. The parent takes the decision. In that case, we use the temporal method for remeasurement. When they all three are different, it's a complex multi-currency operation. In that, we use both the methods. So this is one thing that you need to understand, right? Otherwise, there's no such calculation. The other thing in this topic, there is no calculation, but very important what is presented where. So, temporal method and current rate method. This again, I've revised it in the syllabus, but this you can write for your reference. What is monetary asset? What is monetary liability? Non monetary asset, non monetary liability. First, you should know that. So, I have put up in the notes monetary and non monetary. Okay, so I will write down here for your reference. We are in reading number 3. The first thing I will write what is a monetary and non-monetary asset. That will make it clear for you. So because based on that, we do the presentation. So what is the definition of monetary assets and monetary liabilities? Okay. Basically, the easiest way to understand is liquid assets and liquid liabilities. Okay, that is one way, but still you should know what is monetary assets and what is monetary liability, and then what goes into non-monetary assets. So I will say non-monetary assets and non-monetary liabilities. All right. Now, some of these items, it's better if you remember because that will make your job easier. So, monetary assets are the most liquid assets. So, you will start with cash and receivables. These are the ones that you should understand. They are your monetary assets, something related to current assets, but not all current assets or not all current liabilities. Okay. Inventory and fixed assets. So, all your inventory is illiquid, and all your fixed assets, all of them are non-monetary. All right. In fact, not only fixed, but intangible assets, all long-term assets, intangible assets, unearned revenue. Unearned revenue is also called deferred revenue. Unearned revenue, that is also called deferred revenue. Even that's something which is non-monetary, but my mistake. Unearned revenue is a liability, correct? So unearned revenue is a non-monetary liability. I'm sorry. This is unearned revenue is a non-monetary liability. The one which is here about prepaid expense. So prepaid expense and inventory. Remember, that's why when we calculate quick ratio, we don't take these two. We don't take inventory and prepaid expense. So apart from the because they are non-quick. So apart from these two, you will see all the long-term liabilities. Those are non-monetary. Okay, monetary, just remember easiest way, monetary is cash and receivables. Monetary liabilities are something that you may have to pay immediately or they are due on you in the current year. So it is generally short-term debt and your accounts payable. Your accounts payable. This you have to pay in the short run. But when I'm using, we are not discussing what is current liability. We are discussing what is monetary liability. Everything that you have to pay in terms of cash sooner or later also. So we take the long-term debt also because that is a cash liability, right? The only non-monetary liability that you should remember for your quick reference is unearned revenue. Unearned revenue, deferred revenue or unearned revenue. That is something because you don't have to pay it. You've received it. You have to give the service. This is something that I would suggest you to know because based on this, the treatment under current rate method and temporal method, this you can write it down because this is critical because this will tell you where the CTA is recorded. So now I will write down temporal and current rate method. So we will focus on the temporal method and the current rate method. which currency do we use? Do we use historical rate? Do we use the current rate? Or do we use the average rate? Current rate method is very simple. It doesn't differentiate between non-monetary assets or non-monetary liabilities, right? Current rate doesn't differentiate between that. Temporal, yes. In that case, there will be difference. So when I say monetary assets and liabilities and non-monetary assets and liabilities, that differentiation is for temporal method. So along with asset, liabilities, and equity, which are a component of your balance sheet, what is treated where? That is very important. So under the temporal method and under the current rate method is very simple. These are all assets, liabilities, right? So assets and liabilities are recorded at the balance sheet date. That is the current rate. So they are all recorded at, I will write down current rate, current rate, current rate. Temporal differentiates between both. Temporal says monetary should be recorded at current rate, but the non-monetary are something that you purchased in the past, right? Those fixed assets. So they should be recorded at historical rate. This is where there is a difference between both, which I'm highlighting. Common stock, they both agree that equity was bought, or equity, that is common stock precisely, that is what was bought or issued at the past, in the past. So it has to be taken at historical rate. Under this case, they both do not have a difference in the opinion, temporal method and current rate method. Now comes all your revenue and expenses related, right? So all the revenue, this is where we are focusing into the income statement. Revenue, cost of goods sold, and then there is, after revenue, cost of goods sold, there is one more component, which is where the controversy is, which is depreciation and amortization. Depreciation, amortization. Now, for revenues throughout the year, for this, both agree that anything which is throughout the year, it is better to take the average rate. This is where there is no difference. But cost of goods sold. Now tell me, under temporal method, inventory is under non-monetary, right? Inventory is under non-monetary. So cost of goods sold is related to inventory. So that is recorded at historical rate. Depreciation is related to non-monetary, isn't it? Depreciation is also related to non-monetary, if you realize. So that is also measured at historical rate. This is how you will remember. But current rate method says everything monetary or non-monetary is at current rate. So in the income statement, we will take everything at the average rate only. This is where current rate is pretty much straightforward. Are you realizing this? Understood all of this, everyone in the class? The most important thing, how this is done. All right. Now, any difference in the forex currency gain loss. The final thing I will write down where it is recorded. Any difference in the forex gain loss. Yes, this is what you can help me. So forex FX gain loss due to translation, right? Where do we record that FX gain loss? So any FX gain loss is recorded in the temporal method under the income statement. Under the income statement, it is recorded, right? So your earnings become very volatile. Under the current rate method, it is not recognized in the income statement. It is recognized under OCI as CTA, currency translation adjustment. Is this clear to the class? Everyone? Got it? This is what you need to remember from the, not basically formula, there's a lot more thing, but this is what you need to remember as such in terms of treatment. This is, as per me, the most important thing. All right, because that is what will be reflected. Then there is a section in the topic which is about multinational operation where we calculate effective tax rate. And effective tax rate is very easy. Everyone knows how to calculate effective tax rate because for multinational companies, effective tax rate and statutory tax rate will never match. So it is simply income tax expense over pre-tax profit, that is earnings before tax, simply said as EBT. This is your effective tax rate. It doesn't match with the statutory tax rate when you have multinational operations. That is the only thing. And then there is a final thing. As an analyst, what I will do to make them comparable, analyst will add this OCA back into the income statement. So adjusted income statement will appear in case of current rate method. If we are using current rate method, in that case, we do what? We use the adjusted adjusted income statement. So here I will write down what is the adjusted income statement under the current rate method because I have to make it comparable, right? So under the current rate method to make them comparable, what is the adjustment we will do every in the class? We will add back to the net income the CTA. So whatever is my net income, I will add back the CTA to that. That is what the analyst adjustment will be. Only in case of current rate method, you will have to add back. So whatever is your net income, add the changes in CTA, not CTA just, I will say the CTA changes. CTA is the balance sheet over the period. So any changes in that is what we add. This is the only formula or concept that you need to write it down for your quick remembrance. Clear till this point? Yes. Uh, just a mention about the clean surplus issue. I forgot to mention that we already know the clean surplus discussion, that the difference between the book value of equity or the retained earnings should be due to net income and dividend. If not, there's a clean surplus violation. There is also a mention about the ratios, the pure balance sheet ratio and pure income statement. There's no formula here, just to mention that pure balance sheet ratios like debt to equity, both are balance sheet items. Pure income statement ratio like net profit margin, net income over sales, these ratios are not affected, but the mixed ratios are affected because of the adjustments, right? So that you have to keep in mind. All right. Yes. Now, yes, we'll go to the next reading. In the next reading, we have ample amount of ratios, but these ratios are about the banking Basel norms. So let's go to reading number 3 and the Basel 3 ratios of Basel norms. Yes. Capital adequacy ratio. There are many ratios here. I will quickly write down the components of all these ratios. You don't have to memorize all the ratios because in many cases, you know what happens? The name itself is the formula. Basel 3 capital adequacy ratio, highly testable. In this, you have three ratios, that is CET1, that is your capital CET1 ratio. 81 plus CET1 is your total capital tier 1. There is tier 1 and tier 2. So what is tier 1 capital ratio? What is tier 2 capital ratio? The name is very important because both sound similar. Tier 1 and tier 2. Sometimes we may not realize the name. Okay. Tier 1, and tier 2. What goes into tier 1? There are two types of tier 1. One is called a going concern, and the other one is called 81 when you add 81 also. So tier 1 going concern has CET1, and when I do CET1 plus 81, so these ratios has a minimum. So 81 a additional tier 1, when we add additional tier 1, and tier 2 is actually supplementary capital. So because of this, what does the ratio translate into? The ratio we say is CET1 ratio So CET1 ratio is simply nothing but CET1 capital, which is a part of tier 1. So it is CET1 divided by risky weighted asset. Yes, we say risky weighted asset. Everything is measured in terms of risky weighted asset. So CET1 capital over risky weighted assets. Now comes the tier 1 ratio. Actually, both are components of tier 1 only, but tier 1 ratio, yes, tier 1 ratio is combination of both CET1, CET1 and 81. Okay, additional tier 1 and CET1 divided by risky weighted asset. This is all cumulative. And when we add the supplementary capital also, so the supplementary capital is your tier 1 plus tier 2. So when I do tier 1 plus tier 2 and divided by risky weighted asset, together they will become my total capital ratio. So this will be defined as total capital ratio. Now understand this, that in exam if they ask me total capital, I will take both the capital tier 1 and tier 2. Tier 1 has CET1 and 81 both, but individually they can ask me CET1 also. Along with that, there is some minimum that you need to maintain. For example, for CET1, the minimum that you have to maintain is how much? 4.5 percentage is the minimum, and the buffer additional 2.5, which raises it to 7 percentage. Total tier 1, the minimum that you have to maintain for tier 1 is 6 percentage of risky weighted assets, and total capital ratio is highest, that is 8 percentage of risky weighted asset. This is what you need to remember in terms of ratio, very highly testable. Okay, this is one section which has one of the highest possibilities of expected, in exam. There are ratios to the asset quality. Asset quality of the bank is measured in terms of ratios like debt service coverage ratio and loan to value ratio, what we learned in fixed income also. Here, there is a ratio which is related to loan loss provision, and that sometimes becomes confusing. So, where is that? Where is that? Yes, in terms of asset quality, you will notice all these loan loss provision ratios. Now, to understand these loan loss provision ratios, you will need to know the component. So if you are aware about the component, what is allowance for loan loss and what is provision for loan loss? Provision for loan loss is the amount that you have provided for the loss, and allowance is the cumulative reserves that you've built over the period. Net charge off is the loan's return off minus any recoveries. So this is the amount. Of course, they will probably provide you this amount, but based on this, there are three ratios: allowance coverage ratios, reserve adequacy ratio, and provisioning ratios. These three ratios are critical, right? So I will write down the ratios. Again, it's there in your notes, but we are just summarizing everything at one place. So we have something called allowance coverage ratio, right? Then you have reserve adequacy ratio and provisioning ratio. Reserve adequacy ratio, adequacy ratio, and provisioning ratio. Provisioning ratio. All right. The name, as I say always in ratios, the name itself is the formula. So whenever I say allowance coverage ratio, it will have the cumulative amount which is called allowance for loan loss. So we say allowance for loan loss. That is one thing. In reserve adequacy ratio, also we use allowance for loan loss. So this item, this is your reserves. That is common. Provisioning ratios, in that we use provision for loan loss. So provision is the yearly item, right? Provision for loan loss. So where we use allowance, that is a cumulative amount. Where we use provision is this. In the denominator cover, what do we have to cover? Well, we have to cover the non-performing loans or the loans which are not paying off. So you will see in all the three, there is something called non-performing loans. So I will write non-performing loans. This number will be probably provided to you, but there is something that we write instead of just non-performing loans. We also need to adjust for any recovery. So that is called net charge off. Net charge off. So that net charge off will be the case in this case, the reserve adequacy. This tells you whether the reserves are sufficient. All of these ratios, remember, we need to have them higher. That will tell us that do we have enough reserves or not. All right. This is one point, correct? Then we will have another ratios. Yes, the liquidity ratios. Liquidity ratios are, as I discussed, they are going to be the minimum requirement as per the Basel norms. So for the banks, what are the two liquidity ratios which are very crucial here? Everyone, banks need to have some minimum liquidity, and this is where the timing is also important. So liquidity coverage ratios, should I write it here? Oh yeah, let me write it down here. You will see two ratios here. One is liquidity coverage and net stable funding ratios. So liquidity coverage ratios, liquidity coverage ratio, and stable funding ratio. Two ratios, liquidity coverage and stable funding. Both ratios will, the minimum requirement for both ratio, first I will write down, is that they should be at least greater than 100%. The minimum requirement is that both should be greater than 100%. That is the bare minimum for both. Liquidity coverage means you need to have sufficient assets for the outflows. So, what are the outflows? Banks have to pay off something minimum in the next 30 days. So, it is called 30 days stress or the net cash outflow. So, I have to pay something net cash flow, cash outflow. I will say cash outflow, or it is also called 30 days stress. 30 days stress. Now, I know while you are doing this, you might be wondering, sir, is this really tested? But we are not focusing on that. We are focusing on if they asked. All right. So against the outflow that the bank is supposed to pay, does it have enough of high quality liquid assets? So the numerator is high quality liquid asset. All right. Again, this ratio should be greater than 100%. And net stable funding ratio is available stable funding. Available stable funding, this amount will be provided to you divided by the required stable funding. So we will write required stable funding. Available divided by the required. Both should be greater than 100%. So asset quality, liquidity ratios, and the capital adequacy. These three are important from the banking point of view. The other ratios which are important from your exam point of view are the insurance ratio. And for the insurance ratio, I will summarize it here. We have it in our notes also, and there is some confusion about loan loss and loss adjustment ratio or loss ratio, which is also called underwriting loss ratio. So in the revision, I will just summarize what we did in the class. What is the loss and loss adjustment ratio, which is also called underwriting loss. So first ratio is loss. This is basically from the insurance point of view. Okay. All we did were the banking ratio. So loss and loss adjustment ratio, which is also called underwriting loss ratio. Very important. underwriting loss ratio. This underwriting loss ratio, again, the names they may change, but don't worry about it. It's the same thing. Now, the confusion is that there are two ratios for it. So, which one is applicable for the exam in case, and which one, as per me, has higher chances? I will put across that ratio that you need to remember. So, in exam, they will probably provide you the amount of loss and loss adjustment. Sorry. So you will take the amount of loss and loss adjustment, the name itself, loss and loss adjustment ratio. So that amount will be provided and you will divide it by the insurance company's earnings, that is the premiums. So we divide that by the net premium earned. This is one ratio. The second ratio that you should remember is expense ratio. Now, insurance companies have to pay for expenses which are called underwriting expenses. So we say underwriting expenses. These are expenses conducted to get the insurance business. So these are underwriting expenses divided by net premium earned. Now, the problem is that sometimes instead of net premium earned, they may give you net premium return. So in case of expense ratio, the formula says net premium return. So if they use that, we will take that into consideration. So two ratios, underwriting loss ratio or loss and loss adjustment ratio and expense ratio. Expense ratio. These two put together is your combined ratio. That is your combined ratio. Yes. So in the case of insurance vignette, if they ask, there's a high chance they will ask these ratios. They will ask these ratios. Remember, these are losses or expenses of insurance companies. So they want it to be relatively lower. It's better if they are relatively lower. Combined ratio is nothing but a combination of loss ratio and expense ratio. Insurance companies also pay dividend to the policy holders. So policy holders dividend is also an expense for the insurance company. So we write policy holders dividend ratio. Insurance companies have to pay the dividend to the policy holders. So they have to pay that amount back. So whatever is the dividend paid on the net premium earned. So we write dividend paid. And when I say dividend paid to whom? To policy holders. Dividend paid over net premium earned. That will be also one of my expense. So therefore, combined ratios are of two types. One is a just combined ratio. And then if they say combined ratio after policyholder dividend, we'll simply add both. So if they say combined ratio after policyholder dividend, or simply I will say combined ratio after dividend, combined ratio post dividend, or after dividend. So these both expenses will be added or subtracted because I have the combined ratio also. And now I paid the dividend. Remember, dividend is an outflow to the company. So what you will do, you will add both the ratio. So you will add the combined ratio and you will add the policy holder dividend ratio. I will write policy dividend ratio. These two ratios, when you add these two ratios, so it's a cumulative thing. So first two, loss and loss adjustment plus expense ratio, is your combined ratio. All right. Policyholders dividend is also one of your expense. So when you add that with the combined ratio, you get the combined ratio after dividend. Is this clear? These are the ratios that you need to remember. There is an investment return ratio also. That is how much is your returns on investment, which is like ROA. It's a simple ratio. How much did you earn on the investments? That is not so critical. All right. Because in case if asked, you can answer it. These are all the ratios with respect to financial institution. Yes, FSA has too many ratios. Now comes reading 5. Reading 5 is about reporting quality. In this, there are two models, Benish model and Altman model. So we have something called M score and we have something called Z score. Now, under this model, there is a formula, but do I require the formula to be remembered? You don't need to memorize the formula. It shows about the reporting quality. All you need to know that what is the number that is considered critical or significant here. So Benish model, M score is based on Benish model. Okay. And Z score is also called Altman Z score. Now, Altman Z score or Altman model will give me Z score. Benish model will give me M score. Now, we are trying to assess the quality of the financial reports, right? In this case, we take multiple combination. It's a multi-factor model, as you may see here in the notes. Again, students go into memorizing this, but you are not required to memorize all this at all. This number is always negative. So if the M score is greater than 1.78 negative, then we consider there is a high probability of manipulation. So for the Benish model, I will write that couple of things. Ratio is ratio is always negative. All right. M score, if the M score is greater than negative, what is the magic number here? Negative 1.78. If it is greater than negative 1.78, then it is considered as high manipulation of earnings. But when I say greater than negative 7.8, remember in minus, the smaller the number, the more the negative it is. So remember, less negative means the score will be high. Are you getting it? So less negative means high. So here just write down less negative means high score. Okay, then it's a concern. These 3 points you should know. Ratio is always negative. The M score greater than 1.78 is considered high probability of manipulation, and less negative means the score is high. This is what you should be aware about. The number is more important, and you should know that it is always negative. So they may not ask you the equation, but yes, they would want you to interpret that. Altman model gives us a Z score, and your higher Z score means lower bankruptcy risk. So just remember your higher Z score is lower bankruptcy risk, lower risk of default or lower risk of bankruptcy. All right, that's all you need to remember. There's nothing, a score that you need to remember in this case. In this topic, there was a sustainability concept also. Earnings have to be adequate and sustainable. So there is something called persistence model. Persistence model. This tells us whether the earnings are sustainable or not. And similar to that, there is something called accrual model. So earnings have two components. That is, one is from accrual and then the other component is due to cash flow. So this is like a regression model. So we are forecasting the earnings. We are going to forecast the earnings for the future T plus one based on the past earnings. So we use the AR1 model, auto-regressive model, and here we use alpha plus beta. This beta is going to be very crucial in our discussion. Beta into the past earnings. So beta 1, I will say this is related to what? The past year. So beta 1 into our earnings for T plus error. Plus error. Error is always there in the model. We write down the error. Correct? Everyone? So here I will say persistence when the beta is high. So this has to be high. High means persistence, right? But This is a single factor model. Here we use AR1 model. Now we will use AR1 model only, but we will break down the accruals, the earnings into accruals and cash component. So accrual model does the same thing. We are going to forecast the earnings for the next period, correct? Next period, which is equal to again alpha. Alpha is an intercept here. Plus, I will now have two betas. One is beta for accrual and another is beta for cash flows. So beta, I will write for accruals, beta into accruals. Oh, no, the beta 1 is for cash flows. Sorry. Beta 1 is for cash flows and beta 2 is for accruals. Why? Yes, because we want beta 1 to be higher so that we can consider it is consistent plus the error, everyone. So in this case, beta 1 should be higher than beta 2. Yes, if the beta 1 is higher than beta 2, then we say the earnings are more sustainable because they are more cash based. Otherwise, we say they are more accruals based. This is what you need to remember with respect to accrual model. In this topic, this is the only concept that you need to remember apart from the score and the persistent model. Now, the last reading is about the integration of financial statement. This is the last reading in your FSA. In this topic, we had DuPont formula, which is pretty much easier. I will repeat it even though you don't need it to be repeated, but DuPont is breaking down net income over total equity into several components. So we will break down net income over EBT. This will give you tax burden. This can be broken down as EBT over EBIT. This gives you interest burden. EBIT over sales, that is operating margin. Sales over total asset is asset turnover ratio, and total assets over total equity is your financial leverage. Here, I just have to highlight one thing. In case if you do not have this component, okay, there is a shortcut to derive this component. There's a shortcut to derive this component in for exam. You need the tax rate. So 1 minus your effective tax rate will provide you the tax burden. In case if you don't have it, so whatever is your effective tax rate, 1 minus effective tax rate is your tax burden. This is one thing that you need to remember. Apart from this, in this topic, there is a discussion about net operating asset. So I will discuss what is net operating asset, and related to that, there is accrual analysis. So first of all, we all know what is net asset. Asset is total assets minus total liabilities, but net operating asset, we don't take all the total assets. From the total asset, we exclude cash and investments. So any cash and investments, we exclude. From the total liabilities, we exclude all the debt. So we exclude the debt. The balance is what we call as NOA. So all cash and investments and all debt is what we exclude. That is called your net operating asset. These net operating asset average of NOA, that is beginning and ending divided by 2. This will be utilized to calculate two ratio which is related to earnings quality. One is balance sheet accruals and second is cash flow accruals. So we say balance sheet accruals and cash flow accruals ratio. These two ratios, in case if they ask in exam, we should be ready for this balance sheet and cash flow accruals. This topic doesn't have too many ratios. So here we simply write changes in NOA from last year to this year, whatever is the changes, increase or decrease. In this case, from the net income, we exclude the cash component for investing and operations. So we exclude CFO and CFI. So from the net income, when I exclude the cash flow, those are accruals in my cash. So that is what the ratio is. Do I want both of these ratio to be higher? Well, these ratios basically tell you the changes in your NOA which are not cash related. So we want them to be lower. If these are lower, then we say the company's operating, the earnings quality is sustainable, because then the earnings are more from cash rather than cash flow based. So lower accrual ratio is better. Yes. So we want both of them to be lower. Is this clear, everyone? Right? Then there is a unique ratio in the topic which is called CGO. What is CGO? CGO, we know CFO, operating cash flow, right? CFO is cash flow from operation. CGO is cash generated from operation. So we say cash generated from operation. And cash generated from operations, or CGO, how is it different from my CFO? So CFO is net income plus non-cash minus working capital, right? Here, instead of what is CFO, I will repeat, net income plus non-cash minus changes in working capital. This is what we write for CFO. Just that instead of net income, we here use a more sustainable income, that is EBIT. So instead of net income, we use EBIT. That is the only difference. Otherwise, it is the same. So any ratio that they say about CGO, any ratios, there are several ratios. If they say about what is the CGO to capex, what is the CGO to total debt, so the only problem is about CGO. How is it different? Just that instead of net income, we take operating profit. That's the only difference. Finally, when it's a business combination, there is a ratio which we calculate called implied PE ratio. Now there is no formula as such. Yes, tell me, you have a doubt, please tell me.
So what is this minus?
What is?
What is this written? The
Yeah,
minus?
sorry, I will rewrite it. EBIT plus non-cash minus changes in working capital.
Okay.
Same like what we do for operating cash flow. It is changes in working capital, right? This is what we do for operating cash flow, or simply said, changes in working capital. All right.
Yes, good.
Now, when we do business combination, at that time, we want to derive the standalone value of the company. So for the standalone value of the company, we need to find the implied valuation. So for that, we take the normal P ratio is price over earnings. So here we said we use implied value of company over the implied earnings. Implied earnings. Now, what is implied? This is standalone. In case if they ask, so what we do, we take the combined company's value. From that, we subtract the share of the subsidiary. So we take the market cap of the parent minus subtract the market cap of the subsidiary that we own. So when I say implied, implied is what we take parents amount. Parents amount, for example, for market cap, I will take parents market cap. Let's say for market cap, I will take parent company's market cap minus I will subtract what? The market cap of my subsidiary. So subsidiaries market cap, the proportion that we own. So multiplied by the proportion owned. This is what we will do, and this is what we will get the implied amount. So this is what will give me implied what? Market cap, which is the implied value. Same I will do with implied earnings. If it's implied earnings, so in that case, I will take parents' earnings minus, I will subtract subsidiaries' earnings into my share. So basically, I'm excluding subsidiaries proportion. That is going to be my implied earnings. So we are excluding it. So we get a standalone value. And then when we calculate the ratio, we get a standalone PE ratio, which is called the implied PE ratio. That's it. So many formulas in FSA, and unfortunately, I cannot capture everything because apart from formulas, there is so many concepts in FSA. But these are the bare minimum. This might struggle. This might cause struggle or a pain because It's too many things to remember. Okay. Clear, everyone? Yes. Corporate issuer is a topic where your weightage is 5 to 10 percentage. 4 readings only. The first reading, which is about dividend and buyback or share repurchase, has a couple of formulas. The very important formula is effective tax rate in case of double taxation. So when there is a double taxation, in that case, there is a very easy formula, but effective tax rate. Now, there are two methods in dividend taxation, double taxation, and then there's a split rate also. The formula for both is same, only the rate is different. So here we take corporate tax rate, corporate tax rate. Let's say the corporate tax rate, which is in percentage, will be 30 percentage, right? And then we take 1 minus corporate tax rate. So along with this, we add what? We add plus 1 minus corporate tax rate. Okay. 1 minus corporate tax rate. On this, we do what? We multiply this, assuming the payout ratio is 100%. So we multiply this with the shareholders tax rate, because shareholder will pay dividend at their personal income tax rate. So whatever is the shareholder tax rate, shareholder tax rate, it is the shareholder tax rate which is crucial here. Okay. So that is going to be my double taxation formula. Remember, if the corporate tax rate is 30% and in the shareholder tax rate is 10%, so the the effective tax rate is lesser than 30 plus 10. That is, it is going to be lesser than 40%. That's the hint. In the split tax system, instead of the normal corporate tax rate, you will take the lower tax rate. So that is the split tax rate. So the lower tax rate is the only difference when instead of a double taxation, there's a split system or split tax system. Under the split tax system, this is the only thing, rest all is same. So rest all, there is no difference. So just that instead of corporate tax, we will replace that with lower tax rate, the corporate tax rate. That's it. So wherever you see the corporate tax rate, that will be replaced with the lower tax rate. Rest all, the formula is same, right? This is a very crucial formula in terms of taxation. So you'll remember only the effective tax rate of double taxation, and for split, you will just change the rate. All right. The second is the payout. There are several payout models. One is a constant payout ratio, and then there is a target payout adjustment model. So these are about payout ratios. So payout models, payout, how much dividend you're going to pay from earnings. So there are two models. One is target payout. So you gradually reach to the target. So there is a target payout model, and then there is a constant payout model. Constant payout model doesn't have a complicated formula. You simply take a single rate, so that is dividend over earnings. So it is dividend per share, DPS over earnings per share. Constant, it doesn't change. Target payout, yes, in that there is a two-step process. First, you calculate how much is going to be the increase in the dividends that you will add to the past dividends. So you will take the past dividends, or we are trying to find D1. So D1 is based on D0. D0 is the past dividend, plus we write expected increase in dividend. Expected increase in the dividends. Now this has a formula. So the two-step process is because the past dividend, what is going to be the increase in that dividend? We are assuming here that the existing dividend is below the target. This dividend is always paid from earnings. So we take the forecasted earnings and we do the adjustment on it. So this increase is forecasted earnings into the long-term payout ratio, which is the target payout ratio. This is going to be the forecasted dividend now. minus the original dividend or the last year dividend, D0. This is the gap, but this gap will be adjusted using an adjustment factor. That adjustment factor is number of years of adjustment. So simply I will write divide by n. This is going to be the increase. So what is the increase? It is expected earnings into payout ratio minus the last year dividend divide by the n. N is nothing but the adjustment factor. So if they give you 5 years divided by 5, or they will directly give you 1 divided by 5, 0.2. That is your expected increase. Add that to the D0 will be your D1. This is critical. Okay, this you all should remember. Target payout has a higher expectation, probability of expectation, I think, in exam. Then the remaining formulas is about repurchase or so-called as buyback. In buyback, one thing that we have to focus is what is the impact of buyback. So we are going to understand what is the impact on earnings per share after buyback and book value per share after buyback. Yes, this is after buyback. I will write down after buyback or after repurchase. After buyback or after repurchase, whatever you say, right? Here, normally earnings per share is net income over weighted average shares outstanding, right? So here we write the basic formula of EPS, that is net income over number of shares outstanding. Technically, we write weighted average shares of outstanding, but here it's simply calculated in this way. Book value per share is also book value, that is the total equity value of the company based on financial statement divided by number of shares. This is common, right? This is before or after the buyback. This is a general formula. Buyback can be done with the help of borrowing. So that borrowing will have interest, and therefore that interest amount is adjusted from the numerator. But remember, interest is always 1 minus tax rate, 1 minus tax rate, divided by the shares that are bought back, that is buyback shares. So how many shares you repurchase, those are subtracted. That adjustment in the denominator is same for book value per share also, but in the numerator for book value we subtract the debt amount, not only the interest. We subtract the debt amount, and how much is the debt? It is equal to the buyback. So we say buyback amount, and buyback amount is how many shares you bought and at what price, how many shares you repurchased and at what price. Understood? Now, the EPS falling is a concern. EPS and book value falling is a concern. So, under what case the EPS will increase? So, we say EPS after buyback will increase if, and book value after buyback will increase if. So, EPS will increase, and whatever I'm writing, if opposite happens, EPS will decrease. EPS will increase if the earnings yield, that is earnings over price, is greater than the cost of debt, that is greater than the interest rate, that is the borrowings rate. If that is the case, then the EPS will increase after buyback. Otherwise, it will decrease. If that is not the case, it will decrease. In case of buyback, the price at which you do the buyback, so it is the buyback price. If the buyback price, if it is lower than the book value per share, before buyback, okay? If it is lower than the book value per share before buyback, in that case, only the book value will increase, otherwise it will decrease. All right? Clear, everyone? Yes. Now, there are two coverage ratios, dividend coverage based on net income and dividend coverage based on FCFE. This is also called dividend safety ratio. So we will write dividend coverage ratios based on net income and based on FCFE, based on Based on net income or based on FCFE. Okay. Now, if it is based on net income, what is my dividend coverage ratio? Means, is my net income sufficient to pay the dividend? So we do what? We simply take net income over the dividend. That's it. So net income over dividend. This is nothing but dividend over net income if you do, which is nothing but the payout ratio. So it is inverse of the payout ratio. If it is based on FCFE, we will take, instead of net income, we will take FCFE, but we will also cover what? This is, by the way, dividend coverage ratio. Okay. So dividend coverage ratio, if it is based on FCFE, instead of net income, we will take FCFE. And now, why only dividend? But along with dividend, we will consider the repurchase or the buyback also. So we will add the buyback. So we will take the buyback amount also, or the repurchase amount also. Two things. So if there's a share repurchase, FCFE is more reliable. All right. Correct. This is your corporate issuer reading number 1. Reading number 2 is all about ESG. Under this reading, there is no formula as such, but there is a lot of theoretical discussion that you should know. So reading number 2 doesn't have any formula. So therefore, we move to reading number 3, which is related to cost of capital. And this topic has one of the highest formulas amongst your corporate issuer. In this topic, we have formulas related to what? We have formulas related to cost of debt on one side. So we will focus on all the formulas of cost of debt. Then we have equity risk premium and cost of equity. These are critical formulas. Cost of debt, in the notes, if you see, there are various ways to calculate cost of debt. Let me walk you through that. So this is a dividend safety. Yes, this is about ESG, what we did. And yes, this is about corporate restructuring. Sorry, I will just show you in the cost of debt. There are several ways to measure the cost of debt. Not all of them require the formula because YTM metrics pricing we already know. The one which you should know is implicit rate in the lease. Yes, that one formula that you should know, which is called rate implicit in the lease. This is nothing but the IRR at which the IRR of what? IRR at the point of PVCO and PVCI. So we calculate IRR, which is also called finance lease rate, which is also called finance lease rate. To calculate this IRR, we compare the PVCO and PVCI. So this is assumed a lesser. What is the cash outflow for the lesser and what is the cash inflow for the lesser? Lesser is the one who will lease the property to the lessee. So for lesser, the investment in the asset. So here the components of PVCO are two, that is the assets value, which is what we call as fair value of asset plus any indirect cost. So fair value of asset plus any indirect cost like installation, etc. Indirect cost or repair. This is the lesser's outflow. So this is your CF0. PVCI is inflow, and the inflow for the lesser is from the lessee in terms of lease payment. So whatever is the lease receivable or whatever is the present value of lease payment, present value of lease payments, this is basically in terms of PMT. You will take the PMT and number of years, but at the end, you will also get the inflow if you sell off the asset. So that is the salvage value or the residual value, which is received at the end. So we take present value of residual or salvage value from the asset. All right. Generally, this will become my CF0 and this is going to become my, this will be my PMT. I will write down, this will be my PMT. This will be my FV, and this together will be my CF0 for your reference. When you calculate the IRR, that is going to be your rate implicit in lease, even though less tested, but you should know that. All right, everyone. Check, confirm. Yes. In the cost of debt, you also need to understand how the country risk premium is adjusted. What is country risk premium? Yes, so we will write country risk premium will appear in equity also. Country risk premium. First of all, understand risk premium means anything which is extra. Anything which is extra. So country risk premium is the excess of rate for investing in a country's bond over the benchmark rate. So we take the country rate, and country rate is nothing but that country's bond yield minus the benchmark rate, like the treasury rate. So assuming you are a US investor, so that difference between the rate is called the country risk premium. Let's say Indian government bond is at 7% and US government bond is at 5%. So investing in India is 2% extra or 200 basis point. So it's not as much as, the formula is not needed here as much, but you should know. Now, the remaining formulas are related to equity risk premium. Equity risk premium. Equity risk premium is how much is the excess of return over the risk free. So, simplest way of ERP, equity risk premium, is equity returns minus the risk free rate. Okay, the treasury rate. That is a simple equity risk premium, but this is based on historical. So we say this is based on the past actual return. So this is your historical equity risk premium. However, for forecasting, we require something called forecasted, that is ex ante. Ex ante ERP, equity risk premium. In this case, we have several measurements, survey, but the simplest measurement is dividend discount model and Greinhold-Kroner model. So yes, under this, both the models we've already covered in the past. If I do the dividend discount model based ERP, then my ERP, first of all, is expected return minus risk free. So expected return using the dividend discount model is nothing but cost of equity. So which is D1 over P0 plus G. This is Gordon's growth based expected return minus the risk free is my equity risk premium using the dividend discount model. Understood, everyone? This is forecasted, so it is ex ante. Clear? Very, very important. Okay. Greinhold-Kroner model, ERP is again same formula that you use to find expected return using Greinhold-Kroner minus risk-free. So what was the Greinhold-Kroner expected return? You decompose that into two quick. It is revision that I'm doing. It is the dividend yield and capital gains yield. Capital gains yield, we break down into multiple components, which I will do it right away. That is the change in real EPS growth, expected inflation. This will bring in nominal growth. When I add these two, it will be nominal growth minus the change in shares, because more the shares outstanding, the lesser will be my earnings. So minus the change in shares and plus the changes in P ratio, that is repricing. Okay, change in the P multiple. Okay. These are the components of Greinhold-Kroner. Once you get expected return, subtract risk-free is your equity risk premium using Greinhold-Kroner. Basically the same formula, just simply subtract the risk-free. Is this clear? Once you get equity risk premium, then we start with cost of equity. And for cost of equity, I will write down what are the different methods that we used first. We do cost of equity for a company which is listed, that is for public company. What are the methods we used? Right? There are several methods that we use for public company. Then we use for a company which is not listed, that is the private company. First public company, then second private company, then very important, then are those companies where you are investing in a foreign market. So that is basically investing in emerging market company. So I will write emerging market company cost of equity, right? Then there is a multinational company which is listed in multiple places. That is a global company or global market. So in case of global market, what do we do? So these are global companies related cost of equity. So there are multiple methods in that as well. So there are four broad categories: public, private, emerging, and global. Within the public company, you have the simple dividend discount model, which we already know, but there are multiple other models also. So let us discuss first cost of equity for public company. So cost of equity for, I will write public company. So what all methods we have for public company which is listed? For that, we already have the beta. So we are trying to find dividend discount model using cost of equity. Then we use another method called bond yield plus risk premium. This is so easy but highly tested. A simple CAPM model, which is a single factor model, and then we use multi-factor model, which we've already discovered. So there is none of these formulas are new for you. You already know it. Dividend discount model is dividend yield plus capital gains yield, which is D1 over P0 plus G. That gives you the value. But if I'm trying to find expected return, we already did the expected return, that is cost of equity, which is D1 over P0 plus the growth. Using Kreinol-Kroner, you can add the capital gains yield to be precise, right? Bond yield. So they will provide you with a bond YTM plus a subjective risk premium. A subjective risk premium will be mentioned to you in the question that will be added. CAPM, we all know RF plus beta, RM minus RF, market risk premium, and multi-factor model like Pharma French or Carhart. It can be a two-factor or a three-factor model. Here we take RF plus beta 1 into risk premium 1 plus beta 2 into risk premium 2, and so on. If it's Pharma French three-factor. If it is multi-factor, you Carhart, you can use one more factor called momentum. In case of private company, now for private company, we will do something that we had already covered in the past. So for private company cost of equity, do you remember what two formulas that we use for private companies? For private companies, yes, private companies betas are not available. So we either use the industry beta or the peer company beta. This is where two types of CAPM comes into play. One is expanded CAPM and the second is built up method. Built up CAPM I call. Built up method. In expanded CAPM and under the built up method, under both, of course, we are trying to calculate cost of equity, and both cases cost of equity starts with risk free, correct, plus risk premium. Yes, we do the equity risk premium. I will say risk free plus equity risk premium. But in the expanded CAPM, when I multiply with the beta, I will take the beta of peer company. In the built up method, we take beta of a large cap company, which is always equal to 1. All right. Along with this, we add, along with this is the biggest difference. Apart from this, everything is same. But because of this difference, there is another difference which you will notice is the industry risk premium. So yes, so apart from this, we add two more risk premium under both. That is the size risk premium. Size risk premium we add under both because private companies are of smaller sizes, and we add stock specific or company specific risk premium, or so called as stock specific risk premium. This is common under both. Now in expanded CAPM, we have taken the peer company beta. So in that case, we do not have to take the industry risk premium. But in built up method, you have to add the industry risk premium also. And the reason behind that is because you are assuming a large cap company beta. So that's why you have to add the industry risk premium also. Is this clear, everyone? This is cost of capital for private company. Okay. The third category is cost of capital for a company which is international, or you can say basically a company which is located in emerging market. This is the assumption. So international, or you can say emerging market. Now here the assumption is you are a US investor. So that's why you will add the country risk premium. Very important. So you will calculate the normal expected, the risk premium is based on what a formula. So we will have to add a risk premium, and whatever is your cost of equity, in that we add country risk premium. Very important. Country risk premium. Country risk premium is based on a model. So what we do, we take our company, our country's equity risk premium, but we adjust it for emerging market. So this, when I say country risk premium, this is for emerging markets. So what is emerging markets country risk premium? We take the country risk premium of developed economy like US. So we take the developed economies country risk premium. All right. And then we add, so we take the risk premium, not only country risk, we take the equity risk premium first. Equity risk premium of developed economy, because we are trying to find premium first, right? Plus, we take the sensitivity. This sensitivity can be denoted by any factor. Here you can say it as a lambda. It is an exposure to that economy. This sensitivity is exposure to that economy. Multiply that with the country risk premium. So this, what, when we do this model, what we get is that we get the expected risk premium. I will rewrite this, my mistake. We will say this is risk premium for the emerging market. First, we will calculate the risk premium. So this is country risk premium. Now the question is, how do I get the country risk premium? First of all, once you get the risk premium, you will be able to find the expected returns. So first we find the risk premium for emerging market, which is developed market, plus the sensitivity into country risk premium. Now, country risk premium is calculated using a simple method, which we already discussed in the past. That method is taking the bond yield of the two countries. So if I take the government yield of two countries, government bond yield of two countries, that is the emerging and the developed, right? So if I take the emerging market and the developed market yield, that difference is what we call as country risk premium, which we already calculated. This is the basic method of calculating, but there is something called as the Damodaran adjustment. As per the Damodaran adjustment, so what is the Damodaran adjustment? Damodaran adjustment to country risk premium. He says that, well, the country risk premium is the risk premium for bond. You're trying to derive it for equity. So whatever the country risk premium you have calculated, adjust it for the volatility of the equity market. So how do we do that? We take the standard deviation of that emerging markets equity market. You can take an equity index and a bond index. So that standard deviation ratio, of course, equity markets are riskier. That will be an upper adjustment in case of country risk premium. Once you get country risk premium multiplied with the sensitivity to that country plus the developed country's equity risk premium will give you your risk premium. Once you take that risk premium, add it, and then you get the expected returns. Clear? So that you add it to the risk-free rate, you get the expected returns. Very critical and slightly different also. All right. So this is the third format of cost of capital. Cost of capital for public, private, emerging, and now for a global company. For a global company which is located in multiple nations. So for a global company, cost of equity. In this case, there are two methods. You can take a simple CAPM with a global market index. So here you can take a simple CAPM in simple CAPM, but what you will take your RM, your risk market return will be equal to global index like S&P 500. That is the easiest way, which we call as the global CAPM. This is one method, which is what we call as global CAPM, right? This is the simple method, but it is rarely used in exam. If they ask you, you can use it. You can just take the RMS something else. The other method is unique. Under that, we say ICAPM or international, sorry. This is where we use ICAPM. ICAPM is International Capital Asset Pricing Model. In this is slightly complicated. Your expected return is, of course, RF. But now there are two components here. One is the risk premium, but what do? We take the expected RM of which market? We will take the two component. One is the global market, and then there is a currency impact. So here we take the global market index like the global CAPM. So we will take expected RM of global markets. I call expected RM of global markets minus the risk free. This component is similar to global CAPM, but apart from this, we also adjust for the currency. So we will take both the risk premiums and adjust it, but the second component is very critical here. We will have to adjust for the currency also. This currency adjustment is unique. So what are we going to do here? We will multiply that with the market sensitivities. So here we take the beta of global, how much is the company exposed to the global market. So we will multiply with the beta of that particular stock with the global market. So we will take beta of, let's say, that company with the global market index. That is about how much is the company exposed to the global market. But how much is the company exposed because of the currency? So in that case, we will take the expected return of that currency, yes, foreign currency. If you invested in that foreign currency, what is the return minus risk free into the company's exposure due to that currency. That is called beta. So beta here is nothing but the company's exposure to the currency, to that local currency. This, I don't believe it is tested as much, but in case if it does, this you should be aware about. All right, everyone. Perfect. These too many formulas in case of cost of capital. Cost of capital has several formulas which you should be aware about. Now comes the last reading, and the last reading is about capital structure. This reading has too much of influence from FSA reading number 1. In this case, when we do the adjustment of the corporate transactions, we use the same equity method, uh, business combination method. So here, most of the cases, the calculations are similar to the previous model. There is not as much as a huge difference. Just one adjustment, that when you buy the company, they may ask you to find a premium. What is the premium in terms of percentage? Because between the deal announcement and the deal execution, there is a price difference. So premium formula you need to understand is the deal price that you actually paid and the price of the company before the announcement, that is called the unaffected price. Unaffected price. This difference in the stock, that is called the premium. If they ask you in percentage, you will simply divide by what? Simply divided by the previous price, which is the unaffected price. So we divide it by the unaffected price. Unaffected price, remember, is the price of the company before the announcement of the deal. This one formula, you have to keep it in mind because it is very crucial in case if they ask you how much is the premium. Now, because of the corporate restructuring, there is an impact on the company's financial statements. So if they ask you a ratio, simply they will ask you net debt to EBITDA. Just remember what is net debt. Net debt is company's total debt minus the cash it has, minus the cash and equivalents that it has. So you'll simply subtract all the cash from the company's debt in case if they ask so. Okay, this is only in case of the net debt to EBITDA related ratios, in case if they have mentioned any of such ratios, right? Otherwise, there is no need of any adjustment. That's it. Let me see if there is anything that we missed out in capital structure, corporate structure, restructuring. Are there any formulas? Dividend discount model, the same formulas. Yes. Oh, there is one formula which I have to discuss. Yes, there is a threshold limit for materiality test. Yes. So if when do we consider material? When the decision in acquisition, when do I consider materiality test? If it impacts the company more than 10%, yes. In that case, what will be the impact on? So whenever we are trying to find the impact, remember the materiality. The materiality, if the impact is more than 10%, and in this case there is one thing that is tested which I will discuss. So first of all, what is materiality? If the transaction is large or not. So whatever is the acquisition or restructuring cost, is it more than 10% of the revenue, more than 10% of the asset, then we call it as material. This is one thing that I forgot to mention that you have to understand. Plus, there is a very important thing about the size, which you will see in some of the uh, ratios. Bootstrap effect is basically when a high P company acquires a low P company. So naturally the P ratio increases. That is the bootstrap effect, right? There's no calculation here to be memorized because the ratio is the same. So you just have to see the impact of the two companies combining, what is the impact on their P ratios. All right, what is the next thing? Yes, what is the next thing? Synergies, yes. Okay, this segment, business segment, yes. Under this case, there is something that I had to discuss about the segments. Where is that segment? Yes. Uh, See, there is a ratio here related to segment, sale of asset over segment. In this case, under this, there is a ratio which will tell me whether this is sizable or not. So there is something called segment ratio. Where is it? I don't see it. Basically, it is the segment's percentage over the asset that is allocated to that segment. There is a ratio related to that. Ratio related to that. Okay, let me figure out if there is something. It's not a formula that you need to memorize, but you need to know the impact. I'll just check if we have that. If we have that, maybe not in this topic, maybe some other topic. But there is a ratio which is about how much is the segment allocation of capex divided by the segment asset. So that tells you whether the company is has sufficient assets allocated or not, whether there is sufficient capex to that company or not. So just simply take the capex that is being allocated to the segment, divided it by the assets percentage. So let's say the asset has 20% weight correct? That particular segment has 20% weight in terms of asset, but its capex allocation is less than that. That means the segment is not well funded. This is just one, I think it's a ratio, it's not a formula. Well, that's it. That's the end of all your formulas. Ethics as such don't have a formula, but massive formulas. This is where we've completed all the 9 readings of formulas. I've written it in my way. You should perhaps write it so that you understand it. Or if you already have a revision book, I would generally suggest you to mark it. So F1, F2, F3, right? But if you write it, it stays in your head. If you don't write it, you will just read it and you can't memorize the formulas, right? Of course, when you do revision, this becomes crystal clear what is the purpose of the formula, but it is better you write it. The more you write it, the more is the probability of it getting freezed into your head. All right, I hope you have enjoyed the formula session. There's nothing to enjoy in the level 2, but you should just summarize it. This is only discretionary in case if you need it. If you don't need it, you can probably do it while you are studying it. At that time also, you can mark all this formula. Generally, I recommend students when they are done with the revision of a specific topic, what they should do is that they should just open this formula and write down quickly while I'm speaking, write down all the formulas. That is what you have a separate formula sheet for each topic. All right, perfect. Thank you. All the best.